Hey, it worked. Sweet. Okay, so now I have the library loaded, and now it will start collecting information on, at least I haven't really hit the real world use case why I need this, but we can look and see what's inside there. Of stuff just for no particular reason. Maybe I kind of like this extension. It was added in 14. This is a brand new extension. You don't get those very often. And I don't know. This one's fun. Hopefully you actually don't ever need to use this. But if you do, it is actually pretty handy. So there's new extension, PG. I would say a corrupted page in a table. This is probably the tool that you would work towards. So as an example here, I'm just going to pull up like the first row in this actor table. And I don't want to get too deep into the weeds on how internals of Postgres works, but you can, the two sort of main pieces to get out this. So an xmin, which is like what was the, let's call it the transaction ID of when that data got loaded. And there's a ctid, which is like where's the physical location of that data on disk, right? And so this is the first row on that page. So it's like 0, 1 is the first one. I guess I can show you two of these. So 0, 2 would be the second one, right? And as things get added and deleted and modified, right, the ctids change all around depending on how big the table is and where the data goes. The data was all loaded in a copy statement, so the xmin is the same transaction to put the data in there. Now, what we can do with PG surgery, we get this first function here, which is heap force freeze. And this allows you to freeze a database. So if you've ever heard the term vacuum freeze, right, or had to deal with any of the like freezing settings that are in Postgres, as you're doing vacuums on a table, right, you're trying to sort of mark pages as reusable or potentially save some space or reclaim some space. And what vacuum typically is doing, right, is often you're freezing those tuples to say, yes, this is visible to everybody in the system. And you can do that with vacuum, which is the normal way you do it. In this case, now we can actually freeze a specific tuple in the system, right? So we can freeze specific rows, and I'm passing in the table that I'm putting in, and then an array of the ctid, so array of the physical locations on disk in that table that I want to be able to freeze. And that means it worked, I think. We're going to find out. Yep. So there's a secret transaction ID, quote unquote, which is number 2, which means this page is frozen, which means all queries, all transactions in the system can see it. So now you can see, still in the same physical location. I haven't moved the data or anything like that. It stayed where it was. But I've now indicated to the system, this data is actually frozen. Everybody can see it. And just to confirm, right, it's still the first row, actor ID number 1. So that's heap force freeze. Now we have the more interesting and much more dangerous, here's a good way if you want to screw somebody, not in a good way. This is the function for you. It's called heap force kill. Oops, copy paste is hard. And what this is going to do is we're going to actually mark the data on that, like at that location on that page as bad data. And I'll show you how this works first, and I'll do a little more explaining. Right? So that ran, and again, it's the same. I'm passing in the table name and an array of physical locations. In this case, I'm just doing the first row. So now, if I say, give me the first row from this table, you'll notice that I see number 2. Because when Postgres goes to pull that data, it looks at that first row, and we've killed that row, which means we've marked that as like, that is not good data, like that is no longer valid. Right? So it skips past that and shows me the second row. And if I pull the whole data, you'll see. So now I'm doing where actor ID equals 1. So remember that first row was Penelope Guinness, if I recall correctly. Yep. and now I get nothing back. So there is no more actor ID equals 1. Now you would say, what is the purpose of this? It is not just because you're mad at your employer and you're quitting and you want to screw with all their data. That's not the only reason. So the real reason that you would want this, and I've definitely run this before, and it's always been a real pain to work around. If you start to get corrupted data in your tables, right? Usually I'm going to blame the file system or memory or something, because it's never Postgres. But if you have corrupted data in there, and you'll see messages where, like, usually it's when you're trying to do like a vacuum or maybe like a larger sequential scan, and you see something about error cannot access data in whatever, or something along those lines. You'll see something that looks really bad and indicates you have table corruption. The problem is there's really no way to get around that. There may be other good data on that page that you could get if you could work around that, but because there's a row of bad data in there somewhere, you have no way to do it. So the old way to get around this, I think, we could have gotten around this. So one would be go open the file directly in a file system with a hex editor and do some surgery, aka PG surgery, on that file, right? And you could go mark those pieces of data bad manually. But obviously, when I say open hex editor on the file system in your database, like, you all know that that's not the right answer, even though that might have been the only answer. So this sort of gives you a user space way to deal with this kind of a problem and be able to do some of the same things you would have had to have done, going in with, like, doing it directly on the files. So that's particularly useful. Yes, sir? Probably the main use case that I can think of. I haven't really had to do that one, but I've been in cases, and it's usually like a wraparound situation where there are old tuples in the system that I know maybe portion of the table, that was like older data, and I don't need to really vacuum the whole table, if I had a way to do that. So this would give you that way. So I want to show that again. It's an extension that's included with Postgres, in the primary package. You should have it on any platform you're in. I would have to look. I would not be surprised if cloud providers did not actually give you access to this particular extension. But I haven't checked. So again, this isn't exactly a homework thing, but it depends on what you like to do in your spare time. If you have a cloud provider right now and you want to go look today and see if it's in there on their version 14s, you could probably do all kinds of crazy tricks in those databases, and then they would be like, wow, we probably shouldn't let people have access to that. So if anyone here works for a cloud provider and knows they don't allow that extension, I'd be interested to know it, but I see nobody volunteering that info, so I think it's time to go mess with some people's databases. Maybe. Again, I hope you really don't ever have to use that, but it's kind of good to know there is some options there, and those are way better. I remember one of my earliest, like, corrupted data situations. We used to have a setting. I don't remember what the heck it was called. It was like zero damaged pages. I don't know, is that still in there? Yeah. Yeah. Okay. So what you used to be able to do, you would have to kind of write off the whole page, right? So however many rows are in there, you really didn't know. And what I would do is, like, you could select all. So you'd figure out, like, oh, I've got a damage, like, on CTID 0. If it says 02 is bad, right? Well, I could get select all from actor where the CTID is 01. I could get that first row and then zero out the rest of the page and then get anything that was after that, right? So that was one way you might have done this way in the past, but you were sacrificing any other rows that were on that page, and those might have been good. So this really allows you to, like, pinpoint, this is like, that was like the leeches method, and this is the surgery method. So certainly a better option if you need it. And again, hopefully you won't, but I really think it's interesting. It gets a little bit under, like, what underneath is going on with Postgres, so it's an interesting extension to have. All right, I'll just work my way up here. PSQL tricks. How many people here do not use PSQL for managing their Postgres? Nobody? Really? Oh, that's fantastic. Well, then I will show you these PSQL tricks, because apparently everybody will use them. Really? I feel, I mean, yeah, I don't have a GUI to use, so like, but I could skip it. Like if everyone was like, no, we all use PostgreSQL or whatever, like I'd be, oh, okay, well then let's not worry about that. What are we doing on this? df sum. Oh, right, okay. So here I'm showing \df is to list all the functions that are, so here I'm just picking sum, which is the built-in function, right, to add two numbers together. And I can now do a little better filtering of that. So when you do df sum, maybe I'll run that out. I don't know how many there are. So there are 8 different versions of sum, depending on data types. You can now do a little bit better. So if I do df sum small int, it will just show me the small int one. So if you're trying to figure out, like, for a specific data type, you know, how do I make that work? That also should work for operators. I don't know if I have an example in here for that, but that has been changed for functions and operators in Postgres 14. Let's do DT. I believe the capital T is types. Yes, and so I'm doing the same thing here where I'm, oh, no, this is slightly different, sorry. So this shows types. So the change in, again, this is a Postgres 14 in PSQL. When you search for, I guess these are like aliases or like sort of shorthand version of the name of the data type, like this will pop up. So I can search for int and integer will pop up. I think maybe big int is another one that shows up. There's not actually that many that are that way, but there are a few in the system, and it just makes it a little bit smarter for that kind of thing. It's, I believe it is the standard sort of regexy thing that PSQL uses. I'm going to create an extended statistic called whatwhere on the address table in my database, and then I'm going to analyze it. And the specifics here are not terribly important, but what I wanted to show you was there is now a D capital X to show extended statistics. So if you have created these in your database, and these are generally used for, like, if you want to create statistics on like correlation of different columns within a table. So like if I were doing a query on address where city ID equals blah and postal code equals blah blah, there's no way for Postgres to correlate those two columns together and realize, like, oh, there's maybe some relevance between those two types of data. So I could create statistics that will say, yeah, go look at these two columns and realize what the relationship is, right? Which could help queries that I'm running on that. So if you're doing that kind of a thing within Postgres, and there's actually, again, you could go look up create statistics. There's a bunch of different options for it. If you go and create those, previously we didn't have a really good way to show that. This is now a simple way to show that. Don't confuse it with dx lowercase, which is to show extensions. This is dx capital. So. Let's do di plus film. So here we are getting, so we've added into the di plus and dt plus output, we've added this column, which is access method. And here, in particular, pick this table because we have different access methods. We have different index types on this table. So you can see it shows B tree, and we have a gist index on there. We have another B tree. Previously, this information, it wasn't hidden, but it wasn't in the /di plus output. So we've added it in there in case you're trying to find specific, types of indexes. We've also added this now for tables as well because tables can have different access methods as well. So by and large, I think all you will generally see is heap for most systems as the access method for the table. But I don't know, maybe if you're using Citus, might show you something different. So that's another sort of new thing that has been added into PSQL. So a few little tricks to show you. PSQL still getting better. I don't know why. Apparently it's the best interface ever. I actually do believe that. All right, vacuum. Let's talk about vacuum. How many people here have ever been upset with vacuum in Postgres? Okay, I know you're all lying. If you didn't raise your hand, you're lying. All right, so first thing I'm going to show, there's a new field that's been added into vacuum. called process toast. And what this basically does is it tells vacuum whether or not to look at the toast tables of a given table when it's vacuuming it. So there isn't much to see, but it's one of those, like, I'm going to show you it doesn't do it, because if you look, it doesn't say toast anywhere in here. Let me set that to true and see if we actually get a different output. Probably should have done that the other way around. Oh, hey, look at that. Okay, it does. So there. Right? So normally when you vacuum, it does look at the toast tables. It will vacuum them. But if you pass this process toast as false, then it will not. And you would say, is that actually useful? It's definitely useful. I'll talk about that in 1 second. So I actually think this is the vacuum changes in 14 are why this is like the best release ever. But I want to show you 2 new settings real quick. So there's a vacuum failsafe age and vacuum multi-exact failsafe age. And here's why this is super important. So one of the big problems now that people have is vacuum wraparound. If you're doing high transaction load, or even if you're just unlucky and you have like really large tables, especially if those large tables have really large indexes, right? It can take, I don't know, days sometimes to vacuum a given table, and you really can run into danger. We still hear reports of people that are running into this problem. It's definitely less than it used to be, but I think I'm going out on a limb that from the vacuum perspective of just the regular vacuum age and transactional load and all that, I think 14 like kind of does away with that problem. And the reason it does that is because of these failsafe age parameters. Now, I can't necessarily say if you're having a multi-transact one, and the difference is, so failsafe is generally regarding like just regular transactional workload, right? You're inserting, updating, all that. You have a strong workload like that where deletes are happening and all that. So strong transactional updates like that is failsafe. Multi-transact is more about if you have nested transactions in stored procedures and that kind of a thing. So there's a different sort of counter that you can run into problems with. And I'm not 100% sure we've gotten rid of that problem, because it's really, if you have like the right code where you're just like doing some crazy looping inside of a stored procedure, it's pretty easy to burn yourself out of those multi-transact slots that are in there and do it that way. I don't find a lot of people do that, but I think that's mostly because in Postgres we just don't seem to put that level of logic inside of our functions, which I think is more a sign of the times really than necessarily a Postgres thing. But I will say, like, I've seen folks that are moving from like Oracle into Postgres, or even SQL Server into Postgres, where they're coming with these large batches of stored procedures, and a lot of those have looping logic and that kind of stuff. So that's where you start to run into multi-transact stuff a lot of times. There are other cases as well, but okay. So getting back to why is this so significant? Both the process toast, well, more so this other failsafe age for turning off index cleanup. There was a way introduced in 13 that you could run vacuum on a table and not actually vacuum the indexes. And that was super useful because in most cases, if you are regularly vacuuming your tables and you hit that transaction wraparound problem, right? You start seeing those messages and you have to vacuum the whole thing, and it has to scan the indexes, and that can take a whole bunch of loops. But what we've usually found is out in the field, most people, the majority of their table may be vacuumed already and may be frozen, right? So all the data, especially the older the table is, all the data has been frozen except for very recent data. But the problem is vacuum has to scan everything, and it has to go look at those indexes, right, in the normal vacuum process. So the fact that we can now turn off indexes, and we can also turn off toast data, which often in cases, like toast data is not changing nearly as much as like the direct, if you have like a last updated column and there's some toast data in there, maybe getting modified, but it usually doesn't seem to have the same level of issue that the main heap table has. Auto vacuum will now turn that stuff off by default, right, when you get into the wraparound situation. So it realizes like, hey, I'm in a wraparound situation. Let me ignore the indexes for now. I don't need to do cleanup. I really just need to worry about transaction age, right? And so if you knew that that was in 13 and you ran into that problem, you could go say, I'm going to vacuum index cleanup off in 13 and run it yourself manually, and then it would just look at the heap. And in most cases, that's much faster because, again, a lot of those rows are probably frozen, and that's already marked inside the internal vacuum information. So it can just focus on a really small piece of the table in the heap. It doesn't have to deal with anything else if you knew to turn it off. And the beauty of 14 to me is that that is now automatic. So if you don't know any of this stuff and you're like, I don't know what you just said for the last 5 minutes, right? So you probably are not the one who's going to, or maybe you're going to learn this the hard way, which is like when you're getting transaction wraparound messages and you're like scouring through the docs, how do I figure this out on 13? And 14, like that problem just goes away. And I think in a lot of cases, when we, like most of us have been doing Postgres a long time, like we see those blog posts where the company's like, I ran into this problem, my database is down for 3 days, whatever. And you're just like, well, if you were paying attention, like that would have been easy to fix. But you had to actually like know the stuff that makes it easy, right? Like it's easy when you know how. It's not so easy when you don't know how. And this, I think for like 90+% of cases will make it so you don't have to know how anymore because auto vacuum is going to do it for you, right? So I'm really excited about that. Like we don't think of Postgres as like long-term releases like they do. A lot of operating systems have like, we're going to have this release and this, So to me, like Postgres 11 was the last, like everyone should try to get to 11. When that thing came out, there are a few features in there that I thought like these are critical features that everybody really should have, and that's a good baseline. 12 and 13, great releases. I like putting a lot of stuff on them, but 14 to me is like, if there was a long-term release, 14 would be it, just because of this auto vacuum thing. Because it means that, like, again, 90+% of people will never have to worry about vacuum wraparound. And that, to me, is like one of the biggest scary points when people talk about going into Postgres. It's like, oh, I'm worried because I hear these stories about wraparound, And again, it's usually somebody that's working on like 9.6 that's been in business, for like 10 years running that thing. And you're like, okay, well, this now makes that go away. So super excited about that. Yes. So if you imagine, like, let's say you had a terabyte-sized table, and it had like 10 indexes that were, I don't know, half a terabyte in size. So normally it would have to scan at least 6 terabytes of data to have vacuum run. But if you can turn off the index lookup, now you're down to 1 terabyte instead of 6. So that's a massive speed up. And even better is that Postgres stores the freeze information in the table. So even that 1 terabyte, if you've ever run vacuums on it before, it will know it doesn't have to look at most of that data. It only has to look at what's been recently changed, right? So that shrinks it down even further. So instead of, again, doing like 6 terabytes, and that's assuming that you only had 1 pass over the indexes, and a lot of times you have to do 3 or 4 passes. So you're talking maybe 20 terabytes of scanning, like no matter how fast your file system is, 20 terabytes versus like maybe 100 gigabytes of data that has changed recently in just a heap. Like that's the difference. And it's really just, it will get you out of the wraparound situation. Now you still would want auto vacuum to go back and run down that table again, because it will probably want to do index cleanup at some point, right? But for the wraparound purpose, to get out of that situation, it'll automatically switch to that mode, run it on that, and then it will go back and run it separately once you're out of danger on wraparound. So yeah, that's to me, like I was like extremely happy to see that get in. All right, getting low on time. I jabbered too much. I'm going to blow through a few of these pretty quick. There's some new utility functions, PG wall replay pause. So this is if you're doing like hot standbys and you're have wall going on and being right over there. And I get this as an error because I'm not on a standby. I'm on the main one. But there's actually a number of different functions for managing that wall replay that have been added into Postgres 14. So if that's the kind of topology that you run, I would definitely say check those out. And that's just kind of allows you to pause and unpause, right, and kind of step your way through just to see where things are going. Oh yeah, let's do this one because there are people who are like hackers in the room, and then I get to complain about the work that they do. So there's a new config parameter called enable memoize. And how many of you, you guys, do you know the like you want to fight 1,000? What is it? 1,000 duck-sized horses, or one horse-sized duck, right? Yeah. Okay. Well, how many people are like, I want to fight the horse-sized duck? No, everybody wants the. No, you want to fight the horse-sized duck. Just FYI. If that ever becomes an issue, you want to fight the horse-sized duck, not the 1,000 duck-sized horses. That might be the most important tip you get today. So be aware. I have a little demo here that kind of shows this. So I'm going to create 2 tables, one named duck, one named horse, and I'm going to create an index. New keyboard, still breaking it in. And I'm going to create an index on horse on the fight column. And let's do, just so you can see it. I now have these two tables, one named duck, one named horse, right? And we have an index on this one, and I'm going to set this off. So by default, this is on. If you've ever done something like enable sequence scan or enable bitmap scans, like one of those types of parameters. Also, there's a typo. Okay, so set memoize off, and I'm going to show you the explain. If I put these two tables together. So the basic idea here is I have one table that is, really big, and the other one is really small. When it comes to correlation of data, right? So if you look at this, so what I'm doing is I'm putting 100,000 rows in each table, but in one of them, I've only got like 10 different options, and in the other one I have 10,000 options, right? So small sample size, not size of data, but small statistical difference on the one side and a lot of different options on the other side. So if I do an explain on this, this is all pretty, right, it's small still because it's only 100,000 rows on each side. I'm getting sequential scans. It does a little hash between the two. It joins it all up. Okay, that's great. I don't know why I have that a second time. Good enough. Oh, yeah, it could be. That would make sense. Yeah. So we'll do, I'm going to set it back to default, which is on. Right, show. So now it's on. And I think I was probably watching Avatar when I did this. Okay. So now what it's doing is, now you can see this is what, so this is how it comes, right? So at 14 you would see this. In 13 you would see the previous plan. At 14 you would get this plan. Or if you turn this off, you get this plan. So now we can do an index-only scan on that index that I had on the table, which is probably what you would think you would want to do. And then it memoizes that data, and I still have a sequential scan on duck, and then it pulls it together in a nested loop. So you get a different plan. The specifics of that are probably not actually all that important, other than to, one, realize we have a faster way to do queries like this where you have a small number on one side and a small statistical correlation on one side and a larger one on the other side, which tends to happen a lot. So if you think of like countries and addresses or something like that would be a pretty normal one to see. Or like films and rentals, right? Like your set number of films is not going to be as large as the number of rentals that you've had of that. So there'll be a lot of different cases. And I really wanted to highlight this one because it allows me to complain about the fact that Postgres does not have hints, because obviously Postgres doesn't need hints. It needs these weird parameters that are hard to use, so that if you actually need the behavior to be different in your explain plan, it's really cumbersome to make use of it. And so thank you for that, anyone who has worked on this. Yes, sir? Yeah. Yeah. So exactly that, right? So like again, since I only have 10 different versions, like it understands as I'm scanning that table, or I'm scanning the index even, so it's even better, right? I'm just going on the index, like kind of keep track of those, and as long as that number is small enough, like we only need to pull 10 of those rows into memory, so it's pretty easy. So, but don't lose sight of the fact that we're going to all complain that we don't have query hints. So this one, sure. That was my time. So this is what you're talking about, right? And then it only needed 5 kilobytes for memory. Way lower, on memory usage versus grabbing the whole table. So, I mean, don't get me wrong, like the performance optimization is actually really nice. So I know I maybe lost sight of that in my desire to rail against the powers that be, but that is actually a nice performance benefit. And as a reminder, right, there's actually a lot of stuff it's like in a demos edition. So there's improvements with like sorting and other stuff that are in Postgres 14. So I think anyone, like, you just install the thing, your performance is going to be better. You know, I mean, it's, I guess, the usual expectation, but there are some specific things in 14 that I feel really strong that it will help you on the performance side. So that and the auto vacuum stuff and, you know, like PG surgery and the query IDs, like there's a lot of great stuff in here. Again, I actually have a very long table of contents that we did not get to. So I will post this online. Let's go. I'll just run through, let's see, anything I want to. Oh yeah, like PG lock's wait time. So if you ever wonder, like, how long has my lock been waiting? Sometimes you can derive that from PG stat activity, but it's not always obvious. And sometimes it's a little trickier than you think. So like that's in there. There's a lot of good stuff in this. More stuff for if you're working with stored procedures and all that. So if you want to see the whole script and get all the demos, like, again, you can add me on Twitter. I will post it at some point, either on my blog or my GitHub or something. Or I don't know what, I can email it to you or whatever. So getting the I'm out of time, which I don't think means it's back to the future time. So thank you all for coming. Hopefully you saw a few things that were interesting. Since you're not on 14, maybe this was new, maybe it was inspiring. Seriously, get on Postgres 14. If you don't, then you better be on 15 by tomorrow. So that's it. Thanks, everyone. Yeah, there's going to be a version 4 later on. I have it. So I have it in the title. It's right. Enable memoize. All of those.
Try triple clicking on a line, and you select the whole line in one go.
Oh, okay.
That it's really convenient if you need.
Yes, for that kind of thing. Yeah.
And
yeah.
Double clicking is the word, by the way, so that's also convenient. So
you
don't have to select the word.
I think that's, I was doing a lot of double clicking, but yeah, triple clicking would definitely be better.
Yeah.
So it's really funny. So I just this is.
What is this? Not sure. Is this this bit you're talking about?
No. So this is I don't know if you can see it here. You can't see it, I think, because this thing.
Oh.
So that, right? Like, I always people were complaining. I was like, I don't think it would bother you, but so I usually set this bar to auto hide, right? But like when it auto hides, that doesn't go away because that's where the camera is. So there's this black notch. So there's actually an app you can buy that like hides the black notch. It like paints it with the background, like where the notch is. So part of that is all software that black notch is there. So you can buy that. And I thought like that's the dumbest app ever. So but now I'm like actually using it. So but it's very weird because like the shell stuff is not actually configured the way that I would normally configure it. So this was like it's almost like a loaner laptop. So I was like, oh, I need a laptop to do this presentation at the conference. So let me. Yeah. So this is one of the brand new like M2. This is the MacBook Air 13-inch with the M2 chip. So it's actually really nice that I've used so far. But like so it uses ZSH for the default shell, which I've been a holdout and not switched to that yet on any previous Mac. So.
I'm using it on my MacBook too. I found it reasonably easy to switch to.
Yeah, it's not like you're in totally foreign territory, but there's a few things that, like to get back to the start of a line, I used to do like function back arrow would get you to the start of a line in the shell. That doesn't work in ZSH. And I probably can configure it, right? But it's like you got to go figure out how to configure those things. Pardon? So if you're in like on the command line, and I type a bunch of stuff, and I want to get back to the beginning of the line. So in Bash, you can do function backspace. I do not have that. I think but doesn't this set up multimodal shell? Oh, right. Yeah, so I don't actually like that, which is weird because I am a VI user, but on the shell, I've always found that awkward. for some reason. I see. Yeah. So if you want, like I can just email it to you if you have an email. Maybe that's the easiest. I think that they are, although because I'm filling in, like we need to do some surgery on the schedule to get this in there. No. Pardon? Oh yeah. Let me get out of the way here. I am not. I am Robert. Yeah. Let me grab my power cord there in a second. What's Sure. Yeah, up here.
Oh, okay. Yeah,
NTAO.
Oh, 2 N. You had one N right there. Yeah, and then at gmail.com.
Okay. All right. I will email that to you. I will fix the typos, and then I will email to you. No, so I was the first one, but the speaker who was going to do talk in here was going to do a Postgres 14 talk, but couldn't make it. So they were like, hey, somebody has like a Postgres 14 talk. And I was like, well, I have my demo talk that I can do. So. I'm Robert, yeah. Yeah, give me 1 second. Oh, yeah. There's that.
The mic was working. I think I could hear you.
Yeah, it's on. So let me grab my. Let me unplug my.
Hello? Hello? Yeah? A bit louder? I'm not sure. Hello? Can you hear me? No? Could you hear me from the back? Oh, okay. I can't hear myself. And I'll have to put this. Yeah. This little butterfly thing.
That's
I,
what?
I flew in from London a couple of days ago, so
Boy, you're on so tired.
jet lag. So
Yeah.
I don't know why I woke up at 5 o'clock today. I was like, why I need to sleep and I need my rest.
Yeah, I came in late last night.
Where'd you come in from?
Atlanta.
Atlanta. Okay.
I didn't think it'd be as hard of a transition as it wanted to be.
What's happening?
I don't know.
Hello? Can you hear me? Yeah? Okay.
Y'all get in the back there?
All in the back there, I'll try not to be too loud. Okay. And yep. Hello? Hello? Oops. Crap.
While this is going on, greetings everyone. Welcome to the 11 o'clock session in our Postgres track at the Southern California Linux Expo. We would like to thank our track sponsor, Enterprise Database. EDB helps organizations get the most out of Postgres. Well, nearly 1,500 customers worldwide have chosen EDB software, services, and support. Our offices worldwide enable us to deploy our global expertise locally and support our customers more efficiently. Nabu Bala is here to present Solving PostgreSQL Wicked Problem.
Hi, good morning, everyone. Of course, I'm not Alexander. He couldn't be here. Combination of travel, war, vaccines, everything. Hopefully next year he'll be able to travel and present in person. We did give this talk last year. It was at SCaLE, virtually. I will reference that talk, which is a little bit different, but has a lot more details. So this is a talk about solving some of the thorny problems that some users hit, and unfortunately they hit it at the wrong time after they've been very happy with Postgres for a long time, and then suddenly they get into, these problems. Vacuuming is one of them. So this is a talk about how some of these problems can be solved and a real-world implementation on solving these problems for Postgres. So Alexander is okay, very quickly, Oriole is Baltimore Orioles, the bird, and it's the bird that shows up during springtime. So it's thinking like, oh, this could be a nice springtime for Postgres, future things to look forward to. And of course, birds are dragons also, right? So very quickly, Alexander, he's a Postgres long-time committer and a contributor. He has made a lot of very interesting improvements to Postgres that everyone uses today. Me, I'm a community advocate person. I've been helping Alexander a little bit, helping him give these talks sometimes in person, virtually, as a hybrid talk. Many years ago, when I first was an undergraduate student, the first database I found on a VAX was Ingress, then I decided I wanted to become a database person, and that was. Anyway, so why? Right? What's the basic problem we see? If you go to DB engines, Postgres is beloved, very popular. People love it, and all of that. But if you look at that list, there's more than 300 databases, right? And who really needs 300 databases? Most enterprise customers, we see them running anywhere from 6 to 10 databases. That's pretty bad. But then every month, someone comes up with a new idea, and they build yet another database. And, just creating a zoo of things. So, again, why open source? A lot of users are moving over to Postgres because they found it. They realize it does a lot of things really, really well for what they need. And this code is from Mike Olson. I put him here as the co-creator of Postgres because he was the first one who converted the original Lisp code at Berkeley that was the Postgres prototype into C, and then it became usable as a actually fast database. So he was also the co-founder of Cloudera. He talked about customers just don't want their data trapped in something that they have to pay for every time they try to use it. And Postgres has now become the default database engine where it's safe for you to keep your data because you can move it around and you don't need anyone's permission to run it in a new environment. Then Stephen O'Grady, he's a developer analyst, and recently he wrote a blog about there's way too many databases and everyone is starting to migrate back to relational databases, right? People are falling out of love with NoSQL databases. They found out it does certain things well, but then now everyone is trying to add SQL onto this new database that they said did not require SQL. And then people are just deciding to move back to Postgres and relational databases because it's been proven they can do a lot of things and they're getting better and better. So this is just one of the original paper about Postgres. It talked about how different storage engines can be used and different types of hardware and all that. I won't go into many details about that. But the idea for OrioleDB was that can we go back to the original design principles of Postgres, that it was extensible and you can put in different types of models, different types of data types, different types of query types, and do that. Yeah, you know, nowadays we just don't have DBAs anymore. We have data engineers and data platform engineers, and we have data scientists. So the world of databases has really, really grown. And people have a lot of tools, right? The problem is that if certain tools only work with certain types of databases, then you end up with, again, a multiplication of all these tools, and it becomes a zoo. So what if Postgres could be like a power tool, right? With these adapters where you can do different kinds of things in your environment. And Postgres has the potential of doing that. It's very good, and it can even be better. So what can be done, right? So these are some of the things that have been done in the cloud. Aurora is the most popular example where the Amazon team just took the storage layer of Postgres and replaced it with something completely their own proprietary design for their environment. This does improve a lot of things in Postgres, but it's not open source, so it has no effect on the community edition, right? It's just something that's locked away, only available in Amazon. Azure went slightly a different way. They acquired Citus, and they decided to build Citus into their service. And about a month ago, Citus announced that everything was going to be open source, not just the extension itself, but all the more proprietary enterprise features that they had. They decided to, all be open source. But again, that's an extension that's building on top of Postgres. It doesn't do anything to the Postgres engine itself that moves the state of the art forward. And then GCP recently came out with Alloy SQL, which is basically trying to do what Aurora did, but doing it the Google way, using Google's massive infrastructure and all the things that are hidden in Google Cloud. Again, those things are not open source. So open source efforts, Yugabyte has been around for a while. I worked with the Yugabyte founders very early on when they did their first version, and they decided they wanted a SQL layer on top of Yugabyte. And instead of building their own SQL, I said, Postgres code is there. Why don't you try to use it, figure out what you can do with it? At that time, pluggable storage engines was an idea, and some of the hooks were starting to appear, but it was not far enough for it to be useful for Yugabyte. So they ended up just doing their own thing. And they did release it, and they made it open source. But again, it's their opinionated model of how a distributed storage engine could work with Postgres, and some of it may be useful or not. They are very interested in trying to contribute those ideas back to the community if it fits and if it makes sense, and that might still happen. CockroachDB, I'm from New York. I'm one of the organizers of the New York Postgres meetup. Very early on, they came and showed what they were doing, building a Postgres compatible engine. But because they were using Go, it became a completely different animal. And then many years later, they just decided, change the license. It's not really open source. You can have access to the code, but because it's all written in Go and Postgres is written in C, there's no real synergy there. NeonDB is something fairly new, but it's not built to modify the Postgres core itself. It works alongside Postgres by taking the WAL records and replicating it into S3 and doing all kinds of very interesting things to it. So it is open source, but again, it doesn't try to change the core Postgres. So I'm here to talk about OrioleDB. And what OrioleDB is really is modifying and enhancing the table access methods framework that's in Postgres so that you can build different types of storage engines that are optimized for different types of infrastructure, different types of storage devices, and also different types of workloads, right? Imagine MySQL very early on when it came out, it had MyISAM. It was kind of okay, interesting as a database, but not terribly useful. And then when InnoDB came out, suddenly people woke up and said, okay, we have transactions and we have more advanced methods. And then MySQL really took off. So table access methods, hopefully if it can be really mature, it can really change the way Postgres is being used in different places. And it can also give people a way of customizing the Postgres core without actually messing with the Postgres core. And again, Postgres has this extensions mechanism. Ideally, this is a model that should be carried forward and can be very, very powerful. So what OrioleDB does is a lot of these things were discussed over time, whether Postgres should change things in the core, especially undo logs. Most other databases, especially Oracle, has undo logs and redo logs and those mechanisms, and Postgres doesn't because it has a different method. So OrioleDB implements that. It implements some interesting changes in the way the buffer maps are done, and then for wraparound IDs, it uses 64-bit instead of 32 bits. So I won't go into too much details here, but if you don't know the difference between undo logs and the way Postgres currently does it, you can ask questions. I'll maybe a couple of people can volunteer that. But this turns out maybe to be a more efficient way of managing MVCC. Right? Did I got that right, Bruce? By side, and you can use it for specific tasks that you need, and then all your other data can still be in Postgres. That's really the benefit of it. And then buffer maps. So instead of having a separate buffer map in memory where you have to go through and find out if the blocks are in memory, and then you don't find them, and then you have to go back to the disk and load those blocks. This method has a dual pointer, so you can actually go and find the block, and with one scan, you can figure out whether it's on the disk or in memory, and then if it's on the disk, you can load it. I can't go into the details on this, but this turns out to be more scalable for larger machines with multiple cores and more memory, and I'll show some results afterward. Let's talk about some results, right? So this was a very infamous blog written by the Uber team. Originally, the Uber team started with MySQL, and then they switched to Postgres, and they went pretty far with it. And then another team came in, and they wanted to do something different, and Postgres somehow didn't fit what they expected. And they wrote this blog about how terrible Postgres was and why they moved to MySQL. This caused a big firestorm in the community, because half of the stuff that they wrote about may have just been wrong or misunderstanding. And then the other half were legitimate complaints about the way Postgres worked and why it didn't work for them. So yeah, if you Google Uber Postgres, this is the first thing that comes up. And even though it's about, I think, 5 years ago, it's still #1 hit on Google. So for a lot of people coming new to Postgres, if they just happen to stumble across this, it gives them the wrong impression about whether they should move to Postgres or not. So OrioleDB kind of solves this problem by the design so that you don't have that choppiness that you see over here, and you get a much higher throughput in that same infrastructure. And the same thing down here is that the blue line, you can see, is very, very choppy. So if you don't want to have performance issues, you have to oversize the storage IOPS that you need in order to get stable performance, right? So OrioleDB has a much lower threshold, and so you get much better performance in in the same machine. And then storage efficiency also. This is otherwise referred to as, I think in the blog, referred to as a write bloat, on how, as you use Postgres for a long time, data just kind of piles up, and then the amount of storage that you're actually using turns out to be higher than what you really need. And then you have to go through some cleanup and things that Robert talked about in his previous talk. Let's see, what am I doing for time? So this was an experiment that was done, and I think by October we'll probably redo the experiment once V15 is ready, and then we'll compare it again. But what we were able to do is use the Optane storage device, which is like persistent memory, and treat it as a block device and run databases on it. A few years ago, Dr. Stonebreaker was giving like a road tour to talk about databases. At that time, he had just built a new in-memory database, and he was talking about everything that you can just throw out of the code and the database architecture when you don't have to deal with spinning disks and all the locking and latching that has to be done, And when he showed the efficiency of the code and what the database was actually doing, about 55% of the database operations had to do with storage devices. And at that time, he kind of hinted that Intel was working on something really interesting, which could be like persistent storage memory, where you could use it to store data and you would not have a power down problem. And they had given him a grant to do some work with it. So that eventually became what's now known as Optane, right? So you can now get Optane devices for like 8 terabytes or maybe even 19 terabytes. That's a pretty good size database, So the blue line, so the blue line is just PGSQL, and you can see as the number of connections increases, the performance nosedives, right? This is just PG bench. And then the green line was using OrioleDB on that same device, but through the file system, right? So, just using the OS to talk to the device so that the OS treats it as a storage device. It doesn't know anything about the memory characteristics. And then the red line was treating the device as a block storage device directly and bypassing the operating system. So this creates some interesting use cases where you can take specific tables and lock them into just talking to these devices, and then you can get much, much better performance, right? You can leave a lot of the medium level workloads in Postgres traditional engine, and then just the high write workloads, you can aim it towards these new devices, and that reduces what you would need to otherwise get more IOPS from your cloud provider or size bigger machines or get more memory. So this changes the economic equation on how you use Postgres. And as you see more and more cloud providers, or especially SaaS companies, they're using Postgres as the default engine for their customers, right? And a tremendous amount of their overhead costs goes to paying Amazon or Microsoft or whatever because of some of these overheads that Postgres has. If you can reduce that, more people can benefit from it. The economics of using Postgres, just gets better. Any questions I can take, or we're good? Record level walls, again, is a change. Postgres currently does block level wall, and I think that's tradition for most databases. There's a little bit, some extra things in here where using record level walls made it easier to potentially build a multi-master version of Postgres, where the entire information is on all the other nodes. So when you need to do failover or you need to write to multiple nodes, it becomes easier to deal with that information. So, so I think this also needs a detailed blog to talk about, the benefits of it. And so what are we doing next? So one is that we're tracking Postgres. The extra code and hooks that are needed to make OrioleDB work in Postgres, that's not part of core. And hopefully that's something that can be upstreamed at some point. We're working on that. So what we did is that took all the code necessary to run Postgres and backported it. OrioleDB was originally designed for version 14. We were able to port it to version 15 and test it working. We were able to also backport it to version 13 because we needed to run it in some cloud provider and they were not ready with version 14 yet. And then we're also working on version 16. And then we had one potential customer, a large Postgres-based SaaS company, because they had just migrated from 9.6 to 12. They were not ready to try anything else. So they said, if you could backport it to 12, we can test it side by side with the same exact workload on traffic and see the benefits of it. And then that would help them decide which was the next version of Postgres they wanted to jump to. Do they want to go to 13? Do they want to go to 14? That's something. And because they get a lot of cloud traffic, it would be easy for them to set up a separate Postgres OrioleDB implementation and just pipe the traffic directly to that and test it and give us some feedback. So there were a couple of patches that were committed in the commit fest. Is ongoing now. Don't have too many details on that at the moment. And then upstreaming Postgres is we're trying to contribute some of it into version 16, and all the code is in GitHub, so people are running their own PG bench test and giving us feedback and having pull requests and telling us where things don't work. And one thing we're planning on is to work with, again, large companies that are using Postgres for them to run it alongside their production environment and give us some performance feedback. So, so OrioleDB, the storage engine, is all there in GitHub, and it's there in the open. So people are putting in pull requests and reporting issues there. There's a separate GitHub repo called Postgres, which is our patch version of Postgres that has all the extensions you need. And also over there, you'll find a lot of Docker containers for several operating systems, all the different versions that we're building for. So you can just download the Docker containers and run it, then trying to, build it from source. So when we released this, I think it was in February, we made sure at the first release we changed the license to have exactly the same Postgres permissive license, so that anyone is free to use it on their own. We don't even need to know about it. But of course, people want to use it would come back and ask us for help, because now they're using something that's a little bit different from the community edition. And I think within the first week or so, we got like 1,000 stars, and that attracted a lot of attention. It hit #1 on Hacker News as something, oh, look, all the things that you thought that Postgres would have problems with, here's an attempt to solve it. So a lot of people are aware of that. And in terms of education, we've done a lot of presentations at conferences like this one. The second one has been very interesting. What we have done is that we work with certain large startups who want to use this. And the way we offer a relationship is that not just to help them understand the code and not just take the code and try to run it themselves, but we also started a coaching program to help them hire engineers and make them into Postgres experts, right? So we're using the code here as a learning lab to train people, because one of our goals is to expand the number of people who contribute code back. You just found in one of the conferences I work on, a lot of customers will come and say, we plan to move to Postgres, we're going to go all in, but we need to hire X, Y, and Z kind of people. Can you help me recruit a Postgres committer or a contributor? In the end, it was just, there's not enough of them, right? So advise customers like that or users, say, hire good engineers who want to work for your company, and we can teach them how to become Postgres hackers. And that's a more viable way of expanding the universe of people who are not just using Postgres, but are knowledgeable about Postgres, and then can become productive contributors. Office hours, we haven't really gotten that started yet, but we're hoping as OrioleDB starts to get more public traction, we can do like every Thursday, an 1 hour thing about Postgres code, how to commit code, how to write code, how to understand code, and what the release cycle is. Just, again, try to train people so that they can start to think about becoming part of the Postgres community as contributors. These are some of the few online activities. Let's see here. Right. So so these are YouTube. So if you just put Alexander Korotkov on YouTube, you'll find 2 people, one guy who's into games, and then the other one's Alexander. So put Postgres as your search thing, and you'll find a lot of past presentations. But the really good one was the one that we did with the TimeScale Community Day, where we talked about, because TimeScale is probably one of the most impressive new databases that is built on top of Postgres using Postgres extensions mechanism, And again, back in the day when they first started, they managed to get everything that they wanted done. But now as they're trying to stretch the state of the art, they also wish they could go in and modify some aspects of Postgres to make it easier for them to do some of these new things. So TimeScale, they last time the CEO spoke, they committed to hiring about 12 engineers and paying them just to be Postgres contributors. So this is the level of investment new companies are making into contributing and making Postgres better. And and last year, I think there's probably a recording of the original talk that Alexander gave. I would advise you to go and check that out. And then we gave a talk at Postgres Vision, which was in June, and Alexander had like the last talk, and the title was called The Future of Postgres. So this is not necessarily the future of Postgres, but an idea of some of the things that might affect the future of Postgres, and this is one way to do it. What else coming in the future? So this was a challenge that Dr. Stonebreaker gave at the Postgres Vision keynote. He just said, Postgres is too complicated, it takes too much experience and too much knowledge for people to run it well. Try to simplify it, right? And one way to do it is that instead of having to tune every aspect of Postgres, you can have specific modules that are designed for specific environments, and those should not need to be tuned, right? Out of the box, they should come in with better defaults so that you can just use it without having to be, a 10-year Postgres expert. Some of the other big challenges we see that are wicked problems: connection pooling. Postgres is probably one of the few databases where there's 5 or 6 different connection poolers. Every other database has just decided to just build it as part of their core, and then people just don't have to think about it. Just turn it on, and they have, you don't have problems with too many connections. Multi-threading is something that many community people have talked about. Should we continue Postgres' process architecture, or should we move to multi-threading? And a couple people want to try to solve this, and we're hoping that we can contribute something to that. And then, sharding is something also the community is working on, and our position is that in order for sharding to be really successful, Postgres as a core engine also has to be much, much better, right? Because when you have 1,000 engines running and trying to orchestrate and manage all of that is going to become a worse problem. So core problems need to be fixed so that the future of scale-out Postgres can be even better. And I was talking to some people who work at banks, and data encryption is still a very, very, most of the IT departments are satisfied with encrypting at the file level, at the file system level, but the DBAs prefer to have encryption at the application model. So these are other big challenges we see that as we try to evangelize Postgres and build out the community of more developers, hopefully more people will be able to come in and contribute towards this and accelerate some of the development. So this is a startup I'm working with. They built a really nice cloud-based service where you can take a sample database and run it in a specific cloud, and it will do all the math and show you what's the cost of that cloud service, running a specific database, and your cost per query, cost per operation, and things like that. So we're hoping to use them as a partner and to put OrealDB as an engine that they can deploy across multiple clouds and show the difference and the benefits. So that's a cool thing. And then again, the best way to deliver a database is to deliver it as a database as a service. So we're working with a company called SCaLE. And what was really nice about that is that you could just go SCaLE. You can turn on a 30-day trial. You get a nano instance. And that same service runs on everything from DigitalOcean to Oracle Cloud and Amazon, Google, Azure. It also runs on VMware. But you could go online and try it out. And we have like a 1.5 pager where you can log in with SSH as a super user, just go in, shut down the Postgres instance running, delete the binaries, install OrealDB, and bring it back up, and voila, you have an OrealDB database as a service, right? So it's a quick way for anyone to try things out. You can reach Alexander at OrealDB.com. You can reach me at Postgres@thinkx.com. If you are interested in trying this out, and we would love to work with people to test OrealDB. And that is the end of my talk. I'm ThinkX on Twitter, and normally I give this talk with Alexander online, but it was a little bit shaky how well the Wi-Fi would work, so I'm kind of flying solo. But if you have questions, more technical questions, or you want to learn more about it, everything's on GitHub. There are design documents explaining the architecture, design decisions, and things like that. All the code is out there. Feel free to go in and put in an issue if you have a question about some feature, or you read the documentation and you're interested in learning more about something like that. Everything is there on GitHub. So I hope you will give it a try. And if you're interested in participating or contributing or learning more about the code, or maybe even trying it in your environment, be happy to talk to you about it. and I can take some questions. Yes. Yes. Right, right. Yeah. It's an incubator, right? To try out a new idea. Yeah. No, no, no. We've taken some of those, all the extra code that enhances the table access methods. What Alexander explained to me was that they were very, very biased and oriented towards heap type storage, and it made it difficult to use it for everything else. So, just speculatively, that may be one of the reasons why some of the other engine efforts may have, not failed, but just had difficulty getting traction. So that's why he went a bit further off and started to build this new engine, because he knew that these problems could be solved. And then he worked backwards to figure out what was missing in the table access methods to make things happen. Right. So the engine today is a monolith, and all the pieces are very, very interconnected. Right. So we had the discussion before whether some of that could be useful for anything else. We're still thinking about how that could be done. But right now, you have to take the Postgres v15 code, add these extra 1,000 lines of code, which are spread out about over 12 different functions, and then you have a version of Postgres that can run OrioleDB, right? So a couple of these patches have been committed into v15. Hopefully they will go in. Some had to do with trees and black and red trees, simple things like that. And then there are a couple other things that we're working towards, trying to see that it can get into 16, because these are generic things that will help other companies or other developers try to model their own storage engines. Yeah, these patches have value in themselves, but the new buffer architecture and all of that is just very, very closely tied. That's why it's a monolith right now. So we talked to Alexander, like, can other people see this and either get inspired by it, come back and say, well, if you can make some more abstraction changes, it can be more reusable, right? So that's why, we're going to be talking to some of the AWS people, we're talking to the Yugabyte people, we're talking to the TimeScale people, because these are all the companies that would like to see Postgres customized for their use, but they want to stay within the community and don't want to have forks. Everyone wants to come back into the community stream, and the storage access, table access methods is one way to get what you want, but also be inside the Postgres world. So we're having these discussions, and hopefully, things will get better. Like, a few years ago, I was talking to a startup, and they were building their own Postgres engine designed for AI ML running on GPUs. And they had to hack everything themselves without any guidance from anyone, right? But having this kind of models available, and then showing how maybe Postgres can be extended in other ways to solve other problems, will just bring a big army of developers and talent back into making Postgres better. So that's the hope. Any other questions? So anyways, thank you for your attention, and apparently I stand between you and lunch, but I don't know if they're serving lunch yet. But thank you for coming to SCaLE, and we're very happy to be back in person and present. Please, follow me on Twitter. My DMs are open. You can reach me anytime there. Thank you. I came in 2 minutes under my time.
Yeah.
That's good.
Hello?
Yeah, there you go.
Hello? Oh, that sounds great.
Thank you, whatever that is. I'm in a rush. Do you know where PSAV is, or do they have a radio? They don't have a radio. Can we get them a radio? Okay. You need, well, I don't know. They're wandering around. I'm going to see if they happen to be set up in. Okay. Michael sent me to Carmel. Okay. You do the receiver. I can't find PSAV. What channel are they on?
Hey, someone from Encore, can we check and see why the mic is apparently and it's the cell pack configured in SCaLE? Back and also put the headset on there, not
In the drawer.
somewhere around.
Testing, testing. Testing, 1, 2, 3.
Hello, my name is Bruce Momjin, but it's off. Great. Thank you, everybody. Wonderful to be here at SCaLE. This is my 8th open source event since COVID, so I'm feeling strong. I've actually done 12 events, but like 8 of them were open source. The other ones were church. But it is kind of odd. Like every time I come, I'm like, what's it going to be like? You know, I just don't know anymore. But the 8 have been very good, and this one looks to be good as well. So I'm having a great time, and hope you are too. We're just getting started. This event can get really crowded and really exciting quick, so you can probably expect that to be coming. My name is Bruce Momjian. I am one of the Postgres core team members. I've been with Postgres since 1996, and I've been with Enterprise DB since 2006, so I've seen a lot. My website is right here. In case you're looking for a copy of these slides or a video, there's 58 presentations and 98 videos or something like some crazy number. So again, wealth of information. QR code does work, people say, so maybe you have to get closer, but it does kind of take you to that website. I am really excited about giving this talk today. I always like this talk. I don't know. This was started as a series of blog entries because I was just baffled by nulls. You know, there's this very quixotic behavior of nulls, and it was a series of 10 blog entries on my website. In fact, I have 650 blog entries, so well categorized. So if there's a topic, I probably discussed it. Nulls is one of them. But once I wrote the blog entry, I said, you know, I should kind of bring this together. It feels like it kind of gelled, and I made this presentation out of it. So I hope you enjoy it. I'm glad to take questions at any time. There's really no like sections here. I don't want to say it's a stream of consciousness, but it's sort of a journey through the null landscape. And hopefully from here you're going to get a sense of how nulls behave, where nulls can get you in trouble, and then sort of how to wrestle nulls into behavior that's acceptable to you. I don't know how many of you are application developers. I was an application developer in the 90s. There was a whole bunch of cases where nulls bit us. We're like, why isn't this query, it's like it's got the wrong total. I know there's this amount in the accounts, but when I run this query, I don't get the same number. Why is that? And often the culprit was nulls. So I'll highlight that as I go to kind of give you a sort of places to watch out for. Nulls are incredibly powerful. They're also unavoidable. And they can easily get you in trouble. So hopefully from this talk you're going to come out a little better prepared. Okay. Any questions? Okay. So null. Well, null in English means nothing, but you get philosophical. Is nothing something, right? It's sort of a weird concept. But in computer science, null typically means undefined. And you see that in C. You see it in a variety of languages where if you haven't defined a value for something, it just becomes null, which usually works. But in the data space, nulls can be kind of complicated. For example, what value do you place in a field if it doesn't have a value? If you don't have nulls, well, if it's a string, that's kind of easy. A zero-length string is kind of a good null, right? Like, okay, there's no string length, so it's a null, right? But for numeric types, for example, what value? Because you don't really have a zero-length string for nulls. And then you start to get into the magic value like -1, -99. I don't know how many of you have seen these kind of numbers. Everyone uses a different number in the same application, right? Because there's no predefined, without a null, there's no predefined really idea of what to put for an undefined value. So you hopefully as an organization pick one and keep it consistent, but it doesn't work out that way a lot of times. Same thing with dates. There are a couple of famous databases that have weird dates for nulls. Postgres fortunately never went there, but you can imagine a date has a similar problem. So we've got the concept of nulls. It's in the SQL standard. It's well supported in Postgres. And again, what I'm going to talk about here is related to Postgres, but it relates to all the other relational databases too. Yeah, there's some specific Postgres things in here, but in general, you should be able to get a lot out of this. One of the problems right away for null is it has three purposes, and that is a serious problem. Right? Anything that has three different purposes and they all look the same, you kind of get into trouble. In fact, there was I think one of the SQL standards people actually was thinking we should have three different nulls to represent these three ideas. Now, never went anywhere, but you can kind of see a little bit of the logic of why you might want to do that. The first one is for unknown values. So that would be a use for a null. The second one would be for an inapplicable value. You know, it's not that you don't know it, it just doesn't apply, right? And the third one is like an empty placeholder. And let me give you some examples of that. So let's suppose we have an employee spouse column. I think this is like the clearest one for me, right? So if you put a null in the employee spouse column, does that mean we don't know the spouse's name, right? The person hasn't reported it. The employee's not married, and therefore there's no spouse, right? Not applicable would be a representation of that. Or we're doing a join with the employee table, and the spouse column's not joined. So it's just null, right? So even if you decide as an organization we're never going to let nulls in our system, you still by outer joins can get nulls, right? So this is sort of the problem. I think that avoiding them completely is not a realistic solution. You really have to kind of, buckle down and take it on. And hopefully, as I show you some of the gotchas, if you can keep those gotchas in your head, that'll get you 90% of the way there. So, as I said before, nulls can cause their own problems. Don't use them in inappropriate situations. They have there's a biblical verse that says, every day has enough trouble of its own, right? Don't worry about tomorrow. Every null has enough trouble of its own. Don't add more of them if you don't have to, because it can be a very, very complicated place to be. I love this quote. It's by Joe Selko out of Austin, big Postgres fan, and he's writing about another book that mentioned nulls. CJ Date, obviously, most people recognize that name. And basically, the idea here is that nulls are more trouble than they're worth, and they should be avoided. They're strange, they're inconsistent behavior, source of error, confusion, very true. And he basically says try to avoid using nulls, but then if you have to, use them judiciously. And I think this is a wise approach. You just can't use SQL without at least understanding some of the traps that nulls can put you into. So there's going to be a lot of text here. So if anything you see in red, that was what you should be looking at, because you'll see a lot of text on the screen. And again, if something's red, like the fingernails, you kind of look at them right away. So here you can see the red right here. So what I'm going to show you is I'm going to start really slow, and then I'm going to work up into weird. Okay, so we're going there. Any questions? Okay. First thing, select null. Perfect. But by default, PSQL just reports nothing. And that can be quite confusing because nothing is hard to identify from a zero-length string or from no rows at all, right? I mean, you can see the confusion there. So one thing I did for this test is I actually did a p set, and I made null equal to that string right there. So now if I do a select null, I get something that I can see. So again, this is for illustration. If you haven't done that and you run these in PSQL, you will see different results. So be careful. So how do nulls get into your system? The first way you get them into your system is to effectively, literally insert them. So here's an example. I'm inserting a null into the second column. And as you can see, when I do a select, I get my null back. Right? Pretty straightforward. Here is another way that nulls get into your system, but here we're doing it implicitly. And how are we doing that? We are specifying only one of the two columns from the null test table. So remember back here, I said there's an X and a Y column, right? So here I'm just inserting into the X column. So what you see here is by not specifying the Y column, I implicitly inserted a null into that field, right? Here's another way that nulls can get into your database. You can block nulls, and I do recommend this. Frankly, I have a blog entry about it. Normally when people are creating tables, they think, okay, column name, data type, column name, data type, column name, data type, right? That's usually the way I type my create table statement. One of the things that I recommend for people is think of it as column name, data type, constraint. Column name, data type, constraint, okay? And the reason for that is you're losing a lot of the power of SQL if you are constraining columns that shouldn't be null, columns that you should be unique, columns that maybe you should have a check constraint with a pattern, right? There's a whole bunch of foreign key references. There's a whole bunch of things that we can do with constraints that really increase the power of relational systems. And if you're not using that, you're kind of getting only part of the rich relational experience. Yeah, I can't believe I just used that word, but anyway, I think it's actually true. So if you take a look up here, I created another null test table, and what I did was I added constraints not null and not null. Now, this might be the username. You don't want the username to be null. This might be the user ID. You don't want that to be null. There's a whole bunch of reasons that you might want to do that. Now, sometimes it's implicit. If you use primary key, that is unique and not null on its own. It's like a package. It comes with primary key. But if you're not doing that, then every column you don't want to be null, you should really say, I don't want a null here. Remember, I'm talking about how to avoid some problems. Problems not only from SQL, but problems when applications misbehave. They forgot there's a new column and they don't insert into it, right? You want to see these errors early on rather than collecting a bunch of garbage data and having to go back and clean it up. Because I used to have to clean up that data, and it wasn't fun. Typically, at the end of the month, we had to do the data cleanup. I don't know if anybody else has experience. So, for example, if I insert in a null test 2 and I use a literal null, I get an error. Violates non-null constraint. If I do an implicit null in the final one, again, violates non-null constraint. So, just keep aware of that. Okay. So that's kind of the basis of where we want to go. Now I'm going to show you some of the behaviors that hopefully will give you a pattern of where we're going here. So if I add 1 to a null, I get a null, right? And that actually kind of makes sense. It's an unknown value, or it's a non-applicable value, or it's a value of an outer join, right, that doesn't exist. So adding 1 to it doesn't make any sense. Concatenating it doesn't make any sense. No matter which order you do it in, you get nothing out. And there's many cases when we wrote applications. Remember, I was talking about guarding fields that shouldn't be null. If you're concatenating columns together and one of them's null, all of a sudden you're like, why does my report have this blank there, right? And then I'm the guy who has to go in there and figure out why. How did that data get in there? And then what application is not filling that data in? And right, you can see why it gets to be confusing. So again, a lot of the data sanity would say not to allow null if you're going to be concatenating certain columns together. Null is basically an unknown value in a way. So here I'm inserting. I'm going to show you some of the values into an increment test. So 30, 40, and null. And as you can see, x plus 1, if x is null, then you get null out. Remember, we just showed you that in the previous slide, right? That makes sense. Now, for comparisons, it gets a little tricky because unlike the C language and most languages that we work in, that I work in at least, there's usually a true and false kind of a understanding of comparisons. Either a value is true or it's false. It's non-zero or it's 0 or it's t or whatever. There's always usually some kind of true-false dichotomy there when you do a comparison. SQL doesn't have that. They have what they call a 3-valued logic, which means that a comparison can return true, can return false, or can return null. And there's some ways around that I'll show you in a minute, but effectively, when you're logically thinking about, okay, either it's false or it's true, that's where you're going to get into trouble. And I'll show you some queries where we sort of come at that, oh, either this is true or that's true. No, because there's this third value that can pop up and cause all sorts of problems. So for example, if you compare null to 1, which seems logical, it returns null. It doesn't return false because it's an unknown value. So it may be 1. We don't know. Right? So again, this unknown concept comes across. Does it equal a zero-length string? We don't know. Does a null equal another null? Right? No. We don't know. We don't know if it knows. Maybe they do equal. We don't know. They could have come from 2 different places. Even if they came from the same place, the answer is still null. And this is where you start as an application developer, you start to get confused. You're like, well, logically, if I compare one null column with itself, they're both null, but they're both the same value. No, it doesn't think that way. It's not a thinking thing. If you compare it, it's not. Even this last one, which I love, is null less than null plus 1. Well, you know, no matter what value null has, that's going to be true. But no, we're going to call null here. Okay. So again, this is one of the tricky things you start to get into. Null can represent unknown, non-applicable, or unassigned. So you imagine non-applicable, a non-applicable value. If you increment it by 1, it's still non-applicable, right? So maybe that's the way it should be. So this is the problem. There isn't a one-to-one mapping between unknown, non-applicable, unassigned, and the behavior that you see. That's the primary problem here. So again, that's kind of interesting. In queries, it gets interesting. So if select 1 where it's true, you get a 1, right? But select 1 where a false, whatever that false would be, you get nothing. But if you select 1 where null, you also get nothing. You don't get a null row, you get nothing. Okay, so really the where clause only returns true results, not non-false results. See what I'm saying? Like non-false is not always true in at least the way we think of it, because a not false could also be a null, right? Right, because there's 3 possible values for that conditional expression. So if I say it's not false, you're like, oh, it must be true. No, it could be a null value too. Right, it's kind of really interesting. Null is not false either. So if I say true and null, I get null because it doesn't know. It could be true. It could be not. We don't know. So it's null. Not null is actually null, which I don't even know where to go with that. It's saying that is something so it's taking a null and it's knotting it, right? It's reversing it, but it's still a null. You know how you say like not x equals 1, like it's not x equals 1, right? But this is not null, so it's not. This is not is null. This is not null. It just doesn't know, so it doesn't reverse out with a thing. Any questions aside from head hurting? Okay, yeah, I know. We're only on slide 18, so yeah, we have a lot more to go, and it gets weirder. So yay. That's why I like this deck, because it's just your head is just, I don't know, like wow, like I just don't want to. I don't want to shut my eyes at night, kind of thing. So this is one area that really got me when I was an application programmer, and I can't tell you how many times we'd be like, I don't understand, like these numbers don't add up, right? I used to work for, I used to write financial applications for law firms, so we'd have to end close each month and reconcile the reports, and they would say, why doesn't this add up? And I'm like, I don't know. And I'd have to figure out why, and that usually, a lot of times, the null was the base of the problem, and my misunderstanding of nulls at that time. So we're back to the ink test table. We have 30, 40, and null, right? So this is where your brain kind of starts to kind of fall over, right? So you do, okay, I'm going to take all the values greater than or equal to 0, and I'm going to put them over here, and I'm going to put all the values less than 0 over here, right? Simple. I got all my values, right? Either they're over here or they're over here. What do you see on the, what's this? All your known values, exactly. Because if you look, I got 3 rows here, right? Thank you so much. Got 3 rows at the top. All the ones that are greater than 0 are 2 rows, right? How many rows are less than 0? None. Right here. No values less than 0. Ooh, even if I do this crazy thing, you look at that as your programmer, you're like, it's got to be everything, right? No, it isn't. And this is some of the quicksand that you can get into. That only returns the non-null values. Yeah. So you have to actually, as you're writing queries, if you expect nulls to be in there, you actually have to be proactive about what you want to do with the null values in that table. Because if you don't, you're gonna end up in trouble like this. Another kind of example, not equal to 10. That's another great one. So how many rows don't equal 10? 2 rows. And the last one is crazy. How many rows either equal 10 or they don't equal 10? Right? You would think that would be all your rows. Some of these mistakes my colleagues made, so I have to admit I didn't make all the mistakes. Some of them, the guy would bring me in. He's like, Bruce, this query doesn't return the right number, and I'd be like, okay, walk me through this, and we'd eventually figure out why that was happening. And he made some kind of assumption like this, right? Like either the person's in Pennsylvania, they're not in Pennsylvania, and we're doing a report, right, for taxation maybe. But the two numbers don't add up to the grand total of all the customers. How can that be? Well, it's because we've got null states in there, and nobody had a not null designation on there, so we got a couple null states, and now we have to scramble around to find the person who entered the data. Where is that customer? I don't remember. I put him in, and it was 6 months ago, and let me look him up. And yeah, you're in for a world of hurt, right? A not null would have fixed that, honestly. Not in. If you thought that not in is just its own problem. Because a lot of people, when they think of not in, they think of it as a sort of a set operation. They're like, okay, is it in this set or is it not in this set, right? That's kind of what not in is. So, like you would say at the top, you say, is 1 not equal to 2 or 1 not equal to 3? Well, that's pretty easy. That's true, right? But then if I say, is 1 not equal to 2, 1 not equal to 3, and is 1 not equal to null, that's null. Because we don't know if it's not equal to null. We don't know if it's equal to null, right? Which is pretty clear. That I can get through my head. But we don't know it's not equal to null. Right? So then I have to say I don't know. And I'm going to show you some queries in a minute where we do in clauses, and all of a sudden you do a not in and you don't get any results back. And you're like, what happened? Like, I'm not getting any. There's like, I should get something. Right, and that's usually indication that there's a null in the subquery that you didn't expect. So here's probably the canonical example. Is A in null? Right. So is A in a set of nulls? And the answer is we don't know, obviously. And then is A not in a set of nulls? And we also don't know that. Okay. So that one I can kind of see because I can see the null right there. Right. But when you start to do this kind of thing, it gets a little more confusing. So here we're saying, is A in A or null? True, right? Everyone good with this? Any questions? Okay. So is A in A or null? Well, it's in there. We know it. We're good. We're great. Okay. But then the next one is harder. Is A not in A or null? Well, it's not. We know that's false because we know it's there, right? So we know that it's saying, is it not in A, and we can see the A right there. So we know for sure it's not there. Even though there's another null there, we don't care because we've stopped as soon as we see there's a match, right? But the next two is where everything kind of falls apart. So is A in B? Well, yeah, A is not in B, so we're good so far. Let's go to the next one. Is A not in null? I don't know. I return a not null, null, right? And the last one is A not in a B. Yes, A is not in the B. Is A not in a null? we don't know. 3 valued logic, it returns a null, and we don't know if it's not in there. So you may have a whole bunch of values here, and as soon as you have a null in there, that not in becomes I don't know. And then because the where clause doesn't return anything that is non-true, meaning false or null, it doesn't return false and it doesn't return null, then you don't get any rows. And this was a very common cause of problems. Inquiries, we can expand these a little bit. So is A equal to B or is A equal to null? Well, again, we know A isn't equal to B. That's true. But this is where it gets kind of confusing. So A equals B, we know that's false, right? And usually, so the bottom line, it's false, so we have to keep going with an OR. Remember, with an OR, as soon as we hit a true, we're done, right? But if we hit a false, we got to keep going. So if A equals B, that's false, or is A equal null, we don't know. So we don't return false, we return I don't know, right? And similar at the bottom, is A not equal to B, that's true, right? But again, remember with AND, you have to keep going through all of them as long as it's true. Remember, as soon as it hits false, you know you're false. So is A not equal to B? That's true. Is A not equal to null? I don't know, and then return null. Okay, so that's why the not inquiries are often problematic, because you have that sort of behavior there where it continues going. As soon as it hits a null, everything just falls apart. Even though you kind of know it's not equal to any of them, but there's this null in there, and then you kind of, that's where I'll show you a little later how to fix that. And here it is. So first, how do you compare nulls? This is how we're going to get out of our problem here. So does a null equal a null? Again, we saw before, we don't know, right? It returns null. But the powerful use is the is null clause. Okay, so a null is null. That is true. That's the way you compare for a null. You don't compare it to zero-length string. You don't compare it to another null. Yeah, a lot of people are saying, and this looks really clear, but where you see the people get stuck is they'll say where column not equal to null or where column equals null. Doesn't work. We just saw right here, a null doesn't equal a null, it doesn't know. So you get caught up in a lot of that where people will say column equals null and whatever. And you'll be like, duh, that doesn't work. Or if you're comparing two columns and one of them's null, it doesn't work either. So that's why there's this special is null construct and is not null construct. So where you can specifically, not with an equal comparison, but with an is comparison to say null equals null, yes, null is not null. Remember, where this is the negation of null, and that's false. Right? We're getting actually real values here. Okay, so is null, is not null are actually canonical ways of doing this. So when we talked about doing subqueries and having these nulls come into these in clauses and not in clauses, 80% of the time the fix was to add a clause and the column is not null. Because in a lot of cases, when we were checking for group membership in a table, in a query, which potentially could return some null values, we basically didn't want the nulls to be considered in that case. And as long as we, in that subquery, said is not null, column is not null, the problem went away. We got results that matched. And everything was good, but you have to remember to do that. You have to remember that the nulls are possibly here, and if you don't, then you get caught up, and then you have to go like pepper your queries with a lot of not null to kind of get it working again. I know. I mean, I'm 2/3 down under the presentation. I'm thinking, why did they even invent this thing, right? It's just bad news all around. Sometimes it feels, but as I said in the beginning, it's a need. We have a need to represent unknown values that are not applicable. Null is a good way of doing that, but as application developers, we have to remember they're there unless there's a not null constraint, and we have to specifically plan for them when we're writing our queries. And certain things like a not in query and an in query are just ripe for this kind of confusion, because you're doing a query and it could generate an outer join. Maybe you have an outer join in the query, so then some of the fields will be null. How do you want those to behave, right? It gets very, very tricky. Questions? Yes, sir. I'm sorry, say this again, 15.2? Yes, I'm not, okay, so let me repeat the question. So what he's basically saying in Postgres 15, which is coming out in September, October, which we're going to talk about tomorrow, and I'm not going to cover it here just because it's not out yet, right? When you create an index, and I'm going to show you this in a couple slides, you can have multiple nulls in an index. And what that does, it's a parameter that allows you to basically say, I only want one null in an index. And I'll show you that later. Doesn't really relate to where we are here, because here we're talking queries. That's more talking about an index and index creation. And it was specifically added for compatibility with other systems, that some of them have that behavior. Yeah, good point. Other questions? Okay. So let's get a little more interesting here. So now we have our ink test table, 30, 40, null, and I'm going to be more specific. So here is where I'll say select where column is null, and I get my null out, right? We're here, right? And then down here I said is not null, and I get my column here. So if you want to split your table between nulls and not nulls, this is the classic way of doing it. Another thing that I think is real powerful, and I'm kind of excited about, although it's kind of awkward looking, but it's a way of doing a comparison that kind of papers over the null problem. I guess we can thank the SQL Standards Committee for this, but remember how we have like is null and is not null, and that's how you're supposed to do null comparisons. Well, there's this comparison called is distinct from. Yeah, it's verbose. I'm not a super fan of it, but it's basically saying, it's basically taking our three-valued logic for null comparisons and mapping it down to true and false. Okay, it's effectively like a funnel. It's kind of taking that null out here, and it's effectively mapping it into false. That's how I think of it. But it's doing it at least in a way that's clear to the user, because they can see. So it's sort of like, if you understand the weird behaviors of null, and then you see this is distinct from, you know those behaviors have kind of gone away. That's how in my understanding, I think of it. So here I say, is 2 distinct from 1? Absolutely, right? No question that's true. The next one is actually a surprising answer. Is null distinct from 1? Now, if you say it's unknown, is it distinct from 1? We don't know if it's distinct from 1. Well, maybe we can go back to that old confusion that we had early on. But distinct basically says, you know, we're not going there. An unknown value in 1, in terms of being distinct, it's not a literal 1. That's how only way I can think of it. So null is not a literal 1. It's distinct from a literal 1. It could be 1, but it's not 1 now. So it gets a false, or it gets a true. Okay, and then is distinct null? Yeah, is distinct from null. That actually generates a false. So the nulls actually equal each other. In this case, null is distinct from, and there's also not distinct from, which does the opposite. So again, if you want to bring your null, instead of using is not null, if you want to map your nulls down to a true and false space, that's what is distinct from and is not distinct from does for you. Okay. So for example, at the bottom I say is, remember we still, if we do the comparison ourselves of not equal, we get null, but if we use this is distinct from, then we actually get what we would think of as a 2-valued logic with our nulls. Okay. And we can use this in queries. So for example, this is kind of interesting. And it actually does what we want. And this is, I mean, it's somewhat exciting in the world of nulls. We actually have a clause which takes a null and some other values and splits them up in a way that actually is, in two pieces, right? Not three. So here we say, give me all the rows that are distinct from 30, and we get the 40 and the null. Remember, there's three rows. So we get the 40 and the null, because both of those are distinct from 30. And if we say not distinct from 30, we get the 30, right? So this is kind of nice, supporting all versions of Postgres, supported. This is kind of good. I mean, it's a little verbose, but it takes a little while to get used to, because is distinct from is really is not equal to, in my, right? I mean, that's kind of what it is. It's a little awkward, because when you say is, anyway, is distinct from, which doesn't have the word not in it, is not equal to, okay? And is not distinct from, which has the word not in it, is equal to. Everyone get that? Okay? I'm not happy about that. I'm not going to be singing the praises of that, but that's what we have, okay? I would love it if it was the other way around, but again, we have to follow the SQL standard. Here's another example. This is kind of interesting, where we actually compare the first column to the second column. So we have 1 and 1, 2 and 3, and null, and we say select star from this where is not distinct from y. Remember, a null is not distinct from another null, right? So we actually get this row and that row because they're both not distinct from each other. This is really useful for joins if you're joining, and you want to join two null columns that have match. This is gold, right? Okay. Any questions? Anyone want to run away? There we go. Okay. Here we have another example where we actually have a bunch of values, a null, a 2, a 1, and a null. And we're going to basically order them by their values. And you can see that the order by automatically groups the nulls together. They aren't technically equal to each other, but they go to the same place in the ordering, right? I mean, I guess in some philosophical way they should randomly appear in the table, but we're not going to do that. The SCaLE standard doesn't really want us to do that, and I don't think there's any value to it, but it would be kind of interesting to sort of guarantee we really don't know where the value is. We don't even know where it would show up in the table. No, but we don't do that. We don't do that. So they appear at the end. They're effectively treated equal for ordering purposes, meaning they show up together. Yes, sir. If I did it with a union instead of a union all, I get one null. I think so. Somebody can try it for me, please. I'm going to go on my union all rant right now. There's an argument that I think is valid that says that you should add keywords to do more work, and you should instead of less work. And the union all does not follow that. Well, because the union all will not remove distincts, and the union will remove distincts. Now, there's some set theory reasons that union all is required, but as an application programmer, when I used to do union, I would basically, every time I wrote the word union, I would write the word all unless I had a reason not to. And that catches a lot of people too. When you, the classic case is somebody does a union between two queries, and then the results don't add up because two customers have the same balance, and you do a sum on it, and you're like, what? It doesn't match, right? You the battle scars I have from closing, from monthly closings. But yeah, so that's why a union all is kind of. I believe that somebody will have to test it. select null, union, select null. See what you get. Somebody can raise their hand when they have the answer. Thank you. One other thing you can do is you can put the nulls first if you want. We have a clause here, nulls first, and it'll put it toward the front instead of the back in case you want the ordering to be different. Indexes, and Dave Stokes already talked about that, something coming PG-15, but by default, nulls are not treated equal. And therefore, if you create a unique index, we can have as many nulls as we want. But we do have a setting in PG-15 which changes that. As you can see, I inserted 2 nulls into that table, even though we had a unique index on the column. The system had no trouble doing that for me. Okay. Is there a use case for having a single null in the table? The use case for, so the question is there a use case for having a single null on the table? There are some database products which only allow a single null in an index, a unique index, and some applications rely on that behavior. Now, there's a way of simulating that in Postgres by creating an index only on the null value. Like you can like do a distinct on or something, and there's a way of getting around it. But the easier way is just to use Postgres 15 and just set it when you create the index. Yeah. So yeah, there's some applications that rely on I have a table and I only want to have one null in that table. I don't know why. Nobody's ever explained to me. Yes. Thank you so much. Select null, union, select null returns one null. Thank you so much. Yeah, so select distinct also will return one null even if they're multiple. Thank you so much. Appreciate for that research. Other questions? Okay. Come on in, kids. We're talking about nulls. You're going to love it. We're just saying hi, and we're glad you're here. There you go. Feel free to come in or not. You're good. Appreciate you here. I always used to bring my kids to all these events, so they got to meet everybody. We loved it. Okay. Finally, I want to talk about some of the more esoteric examples of nulls, and I think this is again good to know. First one is aggregates, so nulls and aggregates. So I'm going to create a table called ag test, and I'm going to insert three rows, 7, an 8, and a null. Great. And here I do a query right up here, and you can first see the 2 red markers right away are different. And this is pretty standard SQL. If you say count star, it's just going to tell you how many rows you have, right? Makes sense. If you say count and a column name, it'll count how many non-null rows you have, right? So if you're trying to count the number of non-null rows, that's a really great way of doing it. Sum and min and max, as you can see, actually do not pretend the null row doesn't exist, right? The sum is 15, right? We just ignore the... Now, remember, if we had added these up literally, it would be null. Okay? Yeah, like what? Right? Because remember, if we took 7 and plus 8 plus null, the result is null. But for aggregates, we're in another world, right? So we get the 7, the 8, and the 15, which kind of makes sense. The average is where things kind of go wacky, right? Because I can understand, okay, this 15, you ignore the null, right? The 7 is the min, okay, 8's the max, got it. But the average, it pretends there's 2 rows. It's like the third row just doesn't exist, right? And that's just the way average works. Just live with it. That's what the SQL standard decided for. Another bizarre, interesting, kind of cool outcome is if you delete all your rows and you run the query again, right? You get 0 for select star, makes sense. Select count x makes sense, 0. Sum is null, not 0. What? Right? There's no rows. There's no sum. It's 0. But no, we're going to get a null out of this. That can bite you pretty badly, right? You might do a query, is the sum 0 or not, right? Maybe, maybe not. Min and max works perfectly average. I like those. The sum of the 0 rows is where I start to lose it. Group by is kind of interesting because all of a sudden we're treating the nulls as equal to each other. Right? We proved, remember how I showed that like you add a null to something and you get a null, but for some reason when we do a group by, all of a sudden we're in a different world and the nulls are now equal to each other. So we have 2 null rows, and obviously the count is 0 because they're null, but again, you get that result. It would have been kind of cool if count of x returned null, but it returns 0. Yeah, right? It is what it is. I'm sorry this is a little smaller, but I had to get all on one slide. Another thing that comes to your rescue, particularly for strings, is coalesce. Coalesce, and I know I'm going through this. We've only got 50 minutes. I'm doing my best, but you may want to come back to these slides. I'm just saying, sometimes when I have to get down and dirty with nulls again, I have to go back and remind myself, oh, it's this for this and it's that for that. And so just be aware that don't feel bad if you feel you have to go back and look. It's not, you don't lose any points, right? So coalesce allows me to map a null to a specific value. So for example, I can map, and it's not just strings. I'm giving strings as an example, but here I'm coalescing null to 0, okay, which is great. So now my null, so if you have a query and you know a column might have a null in it, you can just use coalesce. You say, just give me the value, but if it's null, give me 0. Or give me I am null. Or give me NA, right? Here's an example of a query where I basically have a null column and I say, if it's null, just call it NA, and I get a nice NA there. Like, kind of nice. Right? If I'm doing concatenation and I think I might have a null, just make a 0-length string. Beautiful, right? Same thing down here, right? If it's a sum, this is the classic. This is how you get out of that sum problem, right? If the sum is null because there's no rows and I want a 0, that's what you got to do, right? I wish it was just like one button I could tell you to press to get nulls to work the way you wanted to, but it ends up being this crazy grab bag of just like stuff. And that's what we've gotten from the SQL standard. I don't know if I could have done any better. So it is what it is. You can go the opposite way. So you can say you can say null if, which means if the string is an NA, make it a null. That's what you have right up here. So you can see the NA that I inserted up here is now coming out as a null. Right? And this is the combination. We're coalescing null to NA, and then we're making it null again. We're going back. So that's like a loop we've gone around, out and around again. Nulls and arrays. So if the value of an array is null, and you say is null, you get true, because it's a null array. Right? The value is null. But if the array is empty, and you say is that null, it's false. And if you have a null in the array, it's also false. Okay? Remember, this is a null value, and this is a null inside an array. Row expressions, this is kind of interesting. If a row, this is very Postgres specific. If an empty row is null, yes it is. Is a row with a null in it null? Yes it is. And are 2 nulls a null? Yes it is, right? When you mix stuff up, it gets a little more confusing. So a row and a null, is that null? No, because there's values in it, right? If it's a null and a 1, is it not null? Also, it's not true because there's stuff there. And obviously a 1 or true, is it not null? Yes, it is. So again, it's really hard to explain. Like it is a null false, and it is not a null, it's also false, right? Like, figure that one out. Finally, queries in the target list. You don't probably use this very much, but if a query in the target list returns no rows, it actually returns a null. right there. So my select from empty test returns null. So that value of a non-query is null. Kind of cool. And I can check it to see if it's null. In fact, it is. It says true. Okay. This is the conclusion. This is I think it'll make sense to you. And I'm just going to read this. This is from Jeff Davis. I don't think he's coming, but he's one of our Postgres contributors. He says, oh, that makes sense. When you see individual behaviors of null, they look systematic, and your brain quickly sees a pattern and extrapolates what might happen in other situations. This is everybody, right? Often, that extrapolation is wrong, because null semantics are a mix of behaviors. I think the best way to think about null is as a Frankenstein monster of several philosophies and systems stitched together by a series of special cases. And I think I've shown that here today. That's why nulls trip people up, because you just see different behaviors that are not necessarily consistent. I don't know why it was done that way, but it's probably not going to change, and we just have to learn to use it. And hopefully this talk has given you a little more strength to understand when you might get into trouble with nulls. Okay. So thank you very much. And I am out of time, so I appreciate it. I can take one question, I guess, or you can just come up and ask me questions. So thanks very much. Appreciate it.
Can you hear me now? Do you hear that at all? Okay. Normal voice? It'd be something like this? No. Yeah, it's on for sure. 'Cause you can hear it banging. It's picking it up. Okay, is that any better? No, not really. Hello? Hello? Is there a way to... I don't quite understand. Hey, that's, I think, what I'm looking for. Oh, no. The mic is the hardest part. Can you hear me? Hey, okay, you can hear me. Whew. Complicated.
Hello, everyone. Just have a quick announcement before Robert gets going. So we have a track sponsor, EDB, that helps organizations get the most out of Postgres. Nearly 1,500 customers worldwide have chosen EDB software services and support. Our offices worldwide enable us to deploy our global expertise locally and support our customers more efficiently. So with that, I'll turn it over to Rob.
Alrighty. Hey, everybody. I see nobody that came to my first talk is here at this talk, so that tells you something good about the first talk. I guess we'll jump on in there. So there's a fair amount of stuff in here to go through. The talk today, or at least this one, is Advanced Int to Big Int Conversions. It's basically talking about dealing with data type problems at scale in generally high traffic 24/7 environments, all that good stuff that make all your problems harder. As a quick intro, Robert Treat, I help people do Postgres stuff. Most of this, I will post this online later. If you follow me on Twitter at RobTreat2, I'll put a link up. There's probably a version of these slides available publicly now, I think. If you ask me, like, I can definitely send you a copy or whatnot. We'll see. Quick ground rules. Okay to ask questions. Again, the slides should be online at some point. Feel free to take notes if you want to, but it is obviously not required. It's up to you. All the code you're going to see in here, I will warn you, there is some code. It's not designed for you to actually run it. I probably did use it in production at some point, like late at night when something was broken. So this is all based on real code, but some of this is like I went back in the notes or I looked in the server log and I pulled some stuff out. So, you know, your mileage may vary. I would strongly encourage you to not copy and paste this into prod. And I've put some subtle bugs in there just to make sure nobody does that. But it should give you at least enough of an overview to see what you'll have to accomplish if you want to try to use this stuff. So, all right, so let's talk a little bit about the overflow problem. There's sort of the classic version of this data type problem that people tend to run into even still. And it usually the first time like you get a sign of this is you'll see this error message where you get this integer out of range. And it like, I don't know that it's necessarily common, like you have to be running things long enough to get to it. The reason why this comes up is kind of the way that Postgres handles numbers, in quotes, I'm going to put that in quotes, in general. And there are other types that are around, but these are sort of the three most common that people run into. And so there's a small int type, a big int, and an integer. And usually what I find is that when people are doing schema design, they kind of look at like small int as like, if I need numbers that are very small, right, it goes up to 32,000 in value. So if I need a small number, like that's fine. But they'll look at like the big int number and say like that goes to, I believe that's 9 quadrillion or something like that. So it's a very large number. And they say like, well, I'm never going to need that much. And so that's too big. And then they look at the last one, which is integer, which is generally the default that most people think to use. It goes up to 2 billion. And you generally would say like 2 billion ought to be enough numbers for everybody. If you think about it, like if I could have 2 billion customers, like that would be great. I would love to have 2 billion customers or 2 billion users. If I could rent 2 billion widgets or whatever, right, like that would be good. So most people pick that 2 billion number thinking it will be good enough for a very long time and, you know, it'll be great. I'll make a note that the minimum value of these fields is not 0, and we will come back to that in the future before we get done. So how do other ways people get into this? So I said most people end up picking an integer type, but there are other ways that this sometimes gets picked for you. If you have heard of the serial type, that's also commonly suggested for people to use as like an ID column in a table. You pick a serial type, and then it will auto-generate the number for you. So like the first row will get a 1, 2, 3, 4, on and on, and it's great. You'll see this in code like ID serial primary key. Under the hood, it's basically creating an integer type and then creating a sequence and tying that all together, kind of automating that piece. There is a big serial type that is also available in Postgres, but I find that like I guess people don't use it, but probably more realistically, most like frameworks don't make use of it. They just use the serial type, again, assuming 2 billion will be enough. If you do the big serial, it ties it to the big int column, and so it's one way to avoid this problem sort of ahead of time. But again, most people don't end up using that. There's also things like identity columns that you can use. So if you do like ID integer primary key, generated always as identity, it's very wordy. That might also work, but you might still end up with the wrong thing. So just keep that in mind. You may see other versions of schema that are in there where you're not necessarily picking the thing, or some code generation tool has generated this SQL for you because this is easy to port to other databases or whatever. And so you can end up with these integer columns. And in most cases, it'll probably be fine. But just realize, like, this is where I'm going. Like, so you'll have an integer column. You'll start to get an out of range with that. I don't really want to debate logical versus surrogate keys in this talk. That could be a different talk for other people, or like a topic at the bar. I'm also not going to talk about UUID-based primary keys, which are also a thing, and also have many slides that could be spent on them, or beers that could be had, and people could discuss whether those are a good idea or not. So I'm not going to talk about those things. We're talking about real-world problems, like somebody picked the ID as an integer, and now you're dealing with it. So, okay, so remember, with an ID integer, the nature of the problem that we're talking about, you have a table, it has an integer column. Usually when you hit this problem, it's surprising is the first thing, because someone somewhere said 2 billion is always enough, and you have somehow run out of that. And you'll see this, like if you see it in a users table and say, we don't have 2 billion customers, so why do we have an integer out of range error, right? That should not have happened. The other thing is, like, it often takes years to actually get to this problem. So one thing I'll say is, like, the ID, you would say 2 billion, it'll be enough, but maybe enough is not like for the life of the company. Maybe it's like the average career of a DBA, I think, is like 2.5 years or something at the same company. So you're like, it'll at least last 3 years, and so that'll be somebody else's problem in the future. So there are many reasons why somebody might pick this and why you might get stuck with it. The other thing is, of course, remember that it can be that you actually do have that much data. So if you have 2 billion rows of data in your table, the table is going to be fairly large in size, which will make it more difficult to actually work with the data when you're trying to get out of the problem, right? That's just going to make everything harder. So keep all of these things in mind, that like as you're trying to deal with this problem, the unfortunate thing is it'll be more difficult because the size of the data, and probably your production system is broken, and now suddenly, the pressure is on. So we say, like, well, could we have avoided the problem? And people always like, let's go back to talking about that, because if we could just avoid this, that would be better. And so there's some ways people try to do that. You can try to use big int where needed. Again, I said, because this is usually surprising, like, people don't know really where they're going to need it, right? There'll be some feature that they didn't think was going to be 2 billion needed, and then suddenly it becomes something that people use in a different way. A good example, long time ago, I remember Etsy had like a shopping cart ID that was supposed to be per person, and they thought, like, well, this should never get that big. But then people started using the shopping cart as a bookmarking mechanism. So you would find people that had like hundreds of thousands of items like in their shopping cart, and they never attempted to buy it. They just wanted to save it someplace so they could go and get it later. I use that same technique at Amazon. So I don't know about you, but like there are features that are out there. Yeah. Twitter is another good example. Like, it has a like button. I use the like button as a bookmarking feature, so I only have like 10 likes. I know other people that are like, they have a script or something, and every tweet that ever goes out, they just like them automatically, and they've got hundreds of thousands. So you might think that it's, your table's going to be used one way, and then users come along and they bring you some, really interesting use cases, and it leads to more of these IDs getting churned through than you expected. Another big one that I've run into a fair amount, bugs in the ORM code. So I said ORMs, they like to, generate this stuff by themselves. There was a very unfortunate bug in Django a few years back, where if you picked big serial as a primary key, it would create the serial as a big int base serial. So it would actually generate up to 9 quadrillion or whatever, but it would still create the column in the table as an integer field. That's really unfortunate, because if you look at the sequence, it looks like it's going to be fine, and you don't realize, again, that you're going to run out of space until you hit it. So that was a bug that was in Django for a while, and people were trying to do the right thing and not realizing under the hood something bad was happening. The other big thing we see is artificial escalation. Sometimes, something happens, there's a failover event, or like you're doing maybe a logical replication upgrade, and so part of that, you have to manage the sequences yourself. We'll see that people will just bump the sequence value, like, oh, maybe we're at like, 300 million after like 3 years, and we do some operation, there's a system crash, we think we have corruption, just bump all the sequences up by like, 250 million more values. And so you just skip all those, and you'll get up to these numbers much faster than you otherwise would have, right? So we've seen artificial escalation as a big problem. Or one I've also seen where people are like, we're going to shard our database in a couple of years, so we're only going to use like every other number. So we're going to put the odd numbers on this database and the evens on the other one. They don't actually shard their database, but they still leave the old code in that's only, doing every like third number or something. So you're getting escalation much faster than you would have expected in that scenario. So, okay, can we eliminate that problem? No. With artificial escalation, you can look into the table, and here's one, like it's another really subtle one. You get artificial escalation on errors with rollbacks. So like you're doing inserts into a table and it's causing an error. Well, it could still be burning through the sequence value, right, even if you're not putting data in the table. So you have to also be aware of those kinds of things. And it really depends on how your application developers have decided they want to handle that stuff. Right? I like to use the thing that like you put foreign keys into a system so that the errors will prevent problems, and you can rely on the database to help you with that. So that same thing can be a problem, if they say, well, we're going to rely on errors from the database and not do any checking ahead of time to see validity of our numbers. That's the kind of thing you see here, right? We're putting in 3 different values. There are no rows in the table when I count them because I've rolled it back. But if I select from the sequence, the last value is 3, right? So it's used up 3 values even though we have no rows in the table. So that's another kind of thing that like, even if you had picked, the right thing or you think you have to watch for those kinds of issues that come in. This also is an issue with onConflict. So if you ever use insert onConflict, do something else like either update or whatever, people don't realize like those inserts are actually still burning through sequence values. So here, like I've got 1, 2, 3 with that like insert into where I've done union all with multiple ones, so just so you can see the extra bits, right? So like I've burned through a few, even though my onConflict says do nothing. Well, it's too late by that point. Like the sequences have already had the values pulled out. So that was another one where like, insert onConflict comes around, so now application developers decide to adopt that SQL, and you think it's really awesome because it simplifies a lot of stuff, but now you're suddenly burning through, these IDs in a rate that you didn't think you were. So you get extra issue with that. Again, like I said, sometimes people do this on purpose with setval or alter sequence. So that's where you also see people jumping up those numbers on purpose. The other option, I guess, so, okay, if you say like, well, we could use it where needed, but we don't understand what needed means, and we'll probably get that wrong if we try to guess at it. The other one would be to use big int everywhere. And there are reasons that people don't want to do this, and most of it comes down to like disk space or memory or like network traffic or whatever, right? There's more bytes involved if you use big int than the regular integer field. And so people get concerned about that kind of thing. I don't know, I think that is an argument that can be made. I'm not sure how legitimate it really is. Other databases actually do handle it that way. So like, as an example, if you use CockroachDB, integer is just an alias for a big integer, and everything is like, everything is a big int in CockroachDB. and nobody actually seems to complain about that. It's a feature, not a bug, in that database. So that's more philosophical on the part of the database creators, but it does show that like maybe it doesn't matter so much. Granted, that's a distributed database, so the properties it has with memory and storage are a little bit different. So take that with a grain of salt. But that would be one answer, is you just say we're just not going to allow integer fields anywhere, and certainly not in ID columns, and we'll just use big ints, and the extra space it takes, we're not going to worry about that. Of course, also you could use UUID-based primary keys, but I already said we're not going to talk about that. So, did you have a questions or no? Okay. All right. So if we cannot stop it ahead of time, right, we're not going to be able to guess the future well enough to make sure we don't have this problem ever. Then the next solution would obviously be if we monitor the system well enough, then obviously we can stop any production problems. And then I have to remind people, and I think we often forget about this, and all of the systems that we work on are complex distributed systems. I know it may not seem like even a website thing, like WordPress or whatever is not that, but certainly at scale it becomes that. And even that, it's still a distributed system. So it's definitely hard to reason about our systems in a way and have enough knowledge to make sure you're always getting those assumptions correct. And I would tell you that there's no possible way you can actually do enough monitoring to avoid production outages. I don't think that should be like a hot take or anything, but some people seem to think it is. Which doesn't mean we shouldn't monitor at all. So just have limited expectations of how far you'll get. As an example, so one thing you could do, you could have a quick monitor that just like selects the max ID from every table in your system, right? And if you graph that over time or set up alerts and say if it gets over 1.5 billion, then throw an alert and somebody will go look at it and we'll go and address the problem before we actually hit the integer overflow issue. That's probably fine. It does fall down really quickly though when you realize like if we have IDs, we probably have foreign keys, and those foreign key columns we have to be very careful about because we'll have to build extra indexes on them that we may not have needed otherwise, right? We may not have generally been querying against those on a child table. We just needed the referential integrity to make sure that worked. You will definitely have to do it, and Postgres is not adding those indexes by default, right? You have to do that yourself. So make sure you have that. Otherwise, this will sequentially scan the table and may cause issues. Again, you can kind of try to work around that. I don't like many of these workarounds. So in billion row systems I've found, people often just drop the foreign keys because that gets rid of a whole set of problems that you might run into, usually around locking or performance or whatever. Of course, the problem with that is then like it's harder to actually find which ones are foreign keys and not foreign keys, like if you haven't defined it. This monitoring thing also, if you have like integer arrays, an array of values from another table, that's not going to work. Externally referenced IDs, so as you really do start to scale up and you start getting multiple databases and you're reusing IDs like maybe from external APIs and putting those in your system, that is much harder to track, to realize even where these numbers are coming from. You can still graph them maybe, but watch out for that. And then of course you can also have integer columns that aren't part of a foreign key, and that might be something you need to deal with. It's not an ID and it's not a foreign key. We still have to monitor those. So that's great if you know all those, but again, like you're sort of assuming you'll be able to catch every use case in your monitoring and set up these types of queries. I did put together a query that is fairly simple, if not easy to read, and will not possibly fit on any given slide. But you get slides online, and this is probably the one piece of code that I think will actually work if you were to copy paste it. That basically looks at the statistics information within Postgres, and what it basically says is it goes and it looks in there in PG attribute, PG class, PG namespace. It says go ahead and look in all of those. I need every column that is either like an integer or a big int or maybe an int array. You can kind of fudge that as necessary to get those columns back. And then it goes and it grabs the min and max values from PG stats that we have collected when you run analyze, right? So if you're not aware, under the hood, when you run an analyze on a table, Postgres is sampling that table and looking at what is the smallest value and what is the largest value that I've seen in that table and storing that information in the PG stats table. So we can go use that and take a look at it and say, you know, what does Postgres think are the largest values in there, or what are the smallest values and whatnot. We kind of smash all that data together, so I have to do this for each different column type, and then I can put it all together, and then sort of select that back out. So that last piece, this will give it to you if you run it in like Psql to see the data pretty easily. You can obviously change that because we've got them in CTEs to be whatever output you need. So if you were doing like a Nagios check, you know, you probably want like a count on something or whatever, some filtering in there to return like error or not error or whatever, depending on what you need for the system that you're running. So that works. It's definitely much faster because pstats is not that big and you're not scanning these large tables. Even with that query though, like I felt really smart when I finally worked that out, and there's some definitely tricky bits in that when it comes to data type matching and stuff. But even this is not foolproof. It is only as good as your last analyze. So if you're not analyzing your tables regularly, you know, the largest value it's going to find is from whenever the last time you analyzed was. On most systems at that level of operation, we analyze them a lot. Sometimes that leads to different problems. So watch out for that. This also doesn't really help you with negatives. And I'll talk a little bit more about that in a minute. This also isn't going to really protect you from artificial escalation, depending on how quickly you jump through those numbers, right? So if somebody bumps it up really fast, you may catch it, but you may not have time to respond. So very hard to like really stamp this problem out and not have it at all. Probably the only real way, specifically with integers, is to just say we're not going to use integer data types. But a lot of the techniques you're going to see here is like, well, if I run into problems with other data types and I need to convert them, these will help you with those types of problems as well. So talking about the overflow though, all right, so we see this integer out of range. If you get that in production, somebody calls you and says, the system is not working anymore, like we can't sell our widgets, we're having this error, what does that mean, right? And you're like, you saw that in test, right? And they're like, no. Okay, so now your production system basically stops taking orders, and that's bad. If you need an emergency break, like here's, like pull this handle and we can get our business up and running, this will probably work, which is to do an alter sequence and then pass in whatever the sequence name is on that table, and then change the min value and a restart value and set it to the negative max for that data type. So in this case, if we're integer, I'm going to set it to approximately negative 2.1 billion. That will probably work. What will happen is like the numbers will go negative and then they'll start counting back towards 0. So however long it took you to get to 2 billion the first time, if you're lucky, you now have that much time to resolve this issue, and fix whatever needs to be fixed or change the data type, which is probably what you're going to need to do. I will say be careful, break, and just like an emergency break, if your problem is you're going too fast, like the emergency brake helps with that. If your problem, but when you do stop like that, like it's really hard to control a car when you like just pull the emergency brake at like 20 miles an hour. Don't ask me how I know that. So you will be spinning a little bit out of control. Yes, sir? How do I find the last thing I insert? Say again? How do I find the last thing I insert? So it's hard. You just want the max value integer that's less than 0, and that will give you the last one you did. Yeah, don't do that. Right. So there are other things as well that could happen. If you're playing interesting tricks, if you're assuming that the order of integers increasing always is going to match, like here's the latest one, and we always know this is the latest one because it's the highest number in the system, then this is going to break that. So this could still break things in your application, for sure. But the hope is that like if you're inserting data, you at least buy yourself some time to go fix this in a more proper way. And so let's talk about some of the more proper ways. There's actually a few other cases this will break too. I'll get to those. We'll go through these relatively quick, and there's some pseudocode in here. Don't worry too much about it. I'll kind of walk you through it. But imagine if we have a table, right? This table called M. There's an integer and a JSON-B. We ported this for Mongo at one point. And so we have 2 columns, and we run out of space on the integer. Well, the first way to go at fixing this, right, we can add another column, future y, to replace our y column. That'll be a big int. Right, so now you see a table there, future y with a big int. And then you can create a view right? And one of the nice things about Postgres, you have transactional DDL. So you can do some really neat tricks, like you alter the old M table, and you do this in a transaction. So you alter the old M table, rename it to something, like other M, and then you make a view that looks like the previous M table, where you mash the big int and end column together, and just return that back as the Y table. So the view looks like the old one, but under the hood, right, and you see the highlighted part, so we have a view now, public M, and then there's that coalesce of the two fields from the other M table. So I'm just going to pull those two pieces together, right? Now, like I said, it's pseudocode, and I don't want you trying to use it in production, so I don't give you the full deal, but you may have to add triggers for insert and update or delete, depending on exactly what you're doing. And I would say may, which means you probably will have to do that. You may not need all of those. Like if it's an insert-only table, obviously you don't need triggers for update and delete, but you'll probably have to do an insert where you're mapping data around. But this will buy you time to allow you to start backfilling all of the data that was in the first column into that new column that we built. And that's a slightly painful situation, but you backfill all that data, right? So you do an update of every row in the table, and that's only 2 billion updates, so hopefully it doesn't take too long. But at least you're taking new data in, right, while that's going on. And then when you get done with that, again, we make use of that transactional DDL. We can drop the view that we had. We alter the table other M, and now we rename the future Y column to Y, and commit all that, and now you look at the M table, and you've changed it from Y as an integer to Y as a big integer. Watch that sequence, though, because if you haven't addressed your sequence problem, that could bite you, so just be aware of that. And at that point, if you had done like the negative trip, right, if you find that early enough, you can do that without really having to mess with anything. If you flipped it negative, and now you get into this, like this will still work, but you need to make sure you flip it back to something that's over 2 billion. So there are definitely corner cases to watch out for if you're doing that kind of method, but it's certainly doable. Again, have done that in production more times than I really want to admit, and we've had to use that quite a bit, so yay. You can also do that at the table level. So that was at the column level. We just add a new column onto the same table. You may have cases where you need to do it some other way. Here we're doing, again, a new public M, where we have a big int, which is the primary key, but here we have Y as an integer field, so maybe that's like a foreign key or something, right, going to some other table. We create a table future M, and this one we're going to change Y from integer to big int, because maybe the foreign key field now is getting new values in that are not, they're too big for it. And we do the same kind of trick. Here we're going to alter the table, rename that to original M. Again, we create a new view. We coalesce those columns together, right? And we present that to the user. So now when they look at the view, they get public M. And now it looks like there are 2 big int columns as a view. Of course, season with triggers and update, insert, manage that stuff as needed. Definitely depends. Here we probably need one, because we have 2 tables in mind here, right? So we've got 2 tables we're dealing with. So we need triggers on M to handle the inserts and the updates going over to the other table, and adding like where x equals 1. So like if you insert on the new column, we want to populate both fields on the other one. And then actually, you may want to add triggers on the other one to do a back population into the first table. So in any case, once you backfill, right, you update your 2 billion rows. Now all the columns have all the data. And we're going to do the same transactional DDL trick again. We drop the view, we rename the table back, and we commit it. And now you've got, X and Y as big ints. Again, watch out for sequence values. I would say you can play the same trick, right, as views with like tables using logical replication or foreign data wrappers. It is more complex. And definitely want to say I glossed over a lot of things in those examples. I just kind of want to give you like the basic outline of like you can make new columns and new data types. And those could be anything, right? If you were using like a text field and realized like actually we're just storing UUID values, so maybe we want to turn that into UUIDs, right? You could use the same basic method to do that. Like make a new column, put some triggers in place to do the data changes, and have that happen. But I will say the more complex your schema, the more likely this is to be a real pain. Because if you have a lot of like dependent views, or you have triggers on tables, or just any of that, constraints and whatnot, you have to account for all of that stuff you know, in that like DDL transaction piece. So that can be more complicated. If you have like, you know, 20 dependent views on the table in question, you've got to actually go and like reconfigure all those views to look at the new table. So that takes more time and effort. The upside is that's time and effort you can put in, you know, that doesn't, it's not like while the system is live in production necessarily. Like you get those inserts flowing again, get the system up, then all of that is like stuff you can test out on a test system, right, and make sure the code's going to work when you go and deploy it. So I believe it or not, I do sometimes test stuff not directly in production. So there are definitely other problems to consider. I don't want to make it seem like I've solved all the problems. So first thing is you have to think about your app code. So as noted already, some people here do really funny things in their application that they shouldn't be doing. And that's with my full-on DBA hat, because I love telling developers, like, you shouldn't do that. And if I am the developer, I usually say to the DBA, like, well, no, your database should just work better. But in this case, the DBAs are outnumbering the app developers here, so like the app developers are the wrong ones, right? So they're doing it wrong. So if your app was based on, you know, original ORM schema, so if you've used something like Rails or Grails or whatever, Django or any of those, like they usually have like a section where you're supposed to map out what your columns are in the table and what the data types are and all that. You have to make sure you go back and update those models within either like the Django or the Rails code, right? Not just within the database. You need to do it in production out of band of what you're doing inside your app structure, but then also make sure you go and update the app. Another really fun thing that you might run into is, you know, what number types does my language support? And are those the same as what my database supports? So like, let's say you're using a language where it uses unsigned ints instead of ints. And the simple way to think about it is if an integer is like negative 2.1 billion to positive 2.1 billion, an unsigned integer is 0 to 4.2 billion, right? So it's all in the positive space. So when you do that emergency break, you know, I'm going to flip it to negative and that'll solve all my problems. Well, if your programming language doesn't know how to deal with a negative number because it thinks it's an unsigned int, that's not actually going to solve your problem. You're in real trouble now, and I apologize, but you know, Postgres job market is pretty hot. You'll be all right. Just saying. Also, I would say, you know, again, modern systems these days, the complex distributed systems, they're like ogres, which is to say they have many layers, right? As we all recall. Let's say you're getting values from like an API, or you're feeding values into an API from an integer field, and you've published some public spec that says this API returns integer values. And now you switch it to big int values. And you fix all that in your database, and so now your app starts passing out, you know, larger than 2.1 billion values out to the public, and now their apps start breaking. If you have a compiled app where it's compiled in to believe it's going to be an integer, and now you're giving it values that aren't that way, you have to like recompile the app. If you'd like to put those two ideas together, imagine you have a mobile app that has been told it's going to get integer values, and now you need to recompile the mobile app. And the good thing about that is when you recompile a mobile app with an integer overflow fix, there's actually a little flag you can push when you push it to like Google or Apple that tells them, I have an integer overflow problem. Please put this out immediately to all people who are downloading our app and have them update it. And so it'll get through the approval process like instantaneously, basically. Like they just fast, I'm making all that up. Yeah. So if you have that kind of situation with a distributed application where you've sent out code to people, like you have to figure out like how do we get them the new code so they can actually get the new values from the API that we're doing. And if you have multiple apps hitting that database, right, every app has to go and make sure that it's still going to work. That leads me to another little piece of code idea that I've run into that I've had to use. Here's where I create a new primary key selecting function, right? So if you think about the normal definition where you have ID and then it's like next val off of a sequence, next val is just a function. And in Postgres, you can sub in pretty much any other function as long as it, you know, does the right stuff, meaning gives you the data, you know, data that fits in the data type. You can put another function in there and change it from next val. So we've generated different versions of this where we're going to generate a primary key ID. And the way that I've set this one up, you know, we're going to randomly send values through the system. And in this case, you know, we will pick from which sequence we want to actually pull the value from. So we have our regular like PKID sequence, maybe that's the default one that was on the table, right? That's the one that ran you out of space. And now we have an experimental primary key ID sequence. And in that one, we can set the sequence value to negative. We can put it to like 4 billion to see if there's an unsigned int problem. Whatever we need to do. We can go to 9 billion and make sure that like that's going to work. So you can play around with those values. And then the idea is you just feed those values through your system, right? So like 1% of your traffic is going to get these. And also, because this is in a function, you can change the function definition without having to do DDL on the table. So you can also make those experiments really easy to turn on and off. And you can decide whatever is the right percentage. So we usually would go with like 1% or less. Maybe you want 10% or whatever. And you can put more logic into that if you want to, right? You could say like maybe if we see this as an insert on an employee versus a customer or something, like let's send the fake values through. But it allows you to seed those values through your system. Because honestly, like I've found most people don't really know. If you tell them like, hey, we need to switch, this positive number to a negative number, is that going to break your mobile app? Like the mobile app people don't know. Like, they're just not going to know. I'm sorry. Like, so the only way to really know for sure, and it's not even their fault, right? Like there's 7 different API layers away from the database. So like they think it'll work, but in any case, so you can feed that through, make sure it gets all the way through, and see what interesting effects you get. If you have some weird order by because you're a bad person and that's how you code, you can see the effects of that weird order by, like it happens. So I think that's mostly it. I do have some additional readings you can look at. And so we talk about some of these. I'm not going to say where some of these ideas were generated from, but it turns out, totally coincidentally, DoorDash has a couple of blog posts that they've put up. And I include these as slides. So I'll put the slides online. Or I think if you Google advanced int to big int conversions, you probably can find these slides. I think I already have them on my SlideShare account. But there's a couple of different ones where they talk about these same techniques of using triggers and multiple views and that kind of thing in order to reshape their data and like clean up situations. In the heat of like an outage, probably the way you're going to want to do it is, you're kind of focused on just solving your problem. But when you do that one where it's like a new table and that kind of method, you can actually go fix up a lot of problems in there because you can add, not null clauses or, put in new defaults or whatever that you needed before or something. Like any of those, anything you want to clean up, you can do other fields that aren't the integer problem, but like you just want to change some other data types. Anything like that you can do. So there's a few sort of public posts from a couple of companies here that have done this kind of thing and actually talked about it publicly. So you can get even more detail on that. And those really go into more the code piece of it. So other than that, I think that is all for now. Any questions? Any application developers want to heckle me some more? No? Okay, good. All right, well then I guess we're good. Thank you, everybody.
flow test?
Yeah.
Does it?
Yeah. Oh, I thought it would make sense if you wore that one, and then pass it around to whoever.
Oh. Okay, yeah, sure. If you'd like to sit in the audience, it's fine too. But actually, that's a question for Michael. He's in charge. Kidding.
Check, check, check. Testing. Check 1, check, check. Hey, did y'all know that Enterprise DB is a sponsor of our PostgreSQL track here at Southern Cal Linux Expo? EDB helps organizations get the most out of PostgreSQL. Nearly 1,500 customers worldwide have chosen EDB software, services, and support. Our offices worldwide enable us to deploy our global expertise locally and support our customers more efficiently. Hi, everybody. This is the PostgreSQL Ask Me Anything session. We've got a distinguished panel of PostgreSQL experts here. Let's let them introduce themselves, starting from here and going that way.
Hello. I guess this is on. You all hear me? I'm Robert Treat. I've done Postgres for a long time, and nobody will hire me to do it anymore, I guess. So I come to conferences and just talk about it.
I'm Stephen Frost. I'm one of the committers, major contributors to Postgres, and working on it for a long time.
Bruce Momjian, working on Postgres since '96.
Hi, my name is Jaime Casanova. I'm from Ecuador. I'm the CEO of a Latin-based PostgreSQL support company specialized in Spanish support.
I'm Mark Wong. I live in Portland. I think I've been involved since 2003 doing random stuff.
Cool. So this is an AMA. Do y'all have any burning PostgreSQL questions? I have some that I can use in case things slow down a little bit, but let's start with y'all. Who's got a question for the Postgres folks? I'll play Phil Donahue here. Yeah, that's something.
How does somebody get a patch accepted? How does somebody get a patch accepted into the Postgres code base?
Great question. Oh, sure. I have two now. There you go.
Yeah, you do have two. That'd be interesting. So, I mean, just the common way is you post the patch to the hacker's mailing list, and you add it to what is called our CommitFest application. This is commitfest.postgresql.org. There's a number of wiki articles and things like that on wiki.postgresql.org that if you search on that, and so one of them that seems reasonable is if you search for like developer inside of on the wiki site, you can come find so you want to be a Postgres developer thing, and that's got a lot of different resources on it. But the main way of getting a patch into Postgres is putting it up on the hacker's mailing list, and then registering in the CommitFest, and then kind of following along as people respond and make comments and shred it for the first couple of rounds. Is usually how it goes. I don't know if anybody else wanted to. Sure.
Yeah, one of the common mistakes I see is people sort of just showing up with a patch and then trying to go forward with it. If you look at the to-do list, there's a sort of a flow we like to follow, because what we find is if somebody shows up with a patch just out of the blue, we often have to go backward with that patch to say, okay, I understand you have a patch, but like, do we really want this patch? What is this patch trying to solve? Is this the best way to solve that patch? Is there a history of how we've dealt with this missing issue before that makes a patch maybe not the right direction, or where we can give you guidance before you actually start coding something? Then we have to talk about the implementation. How would we go at it? What would the user API be, right? And once we have clarity on that, then the patch is much more likely to be accepted. So a lot of people who are new show up with a patch, could be small, could be big, and there's no reason, there's no explanation of why I care about this change, what it does, why you chose that user API, and then you end up having to sort of undo a lot of stuff to kind of get to the core of the problem. So starting at that, what's at the top of the to-do list in terms of desirability, and then implementation and the user API, and then going to the patch is much more likely. So usually I'm saying talk first, then patch is usually the better approach.
Yeah, I mean, I would certainly agree with that. I think the only thing I was trying to lay out was kind of the mechanics of it. If you have a typo patch, post it to the list and register it in the CommitFest, right? If you're thinking about developing some new capability or new feature, it definitely makes sense to float it on the list first and have a conversation with the hackers about it, just to ideally avoid any wasted effort. Right? That's the idea there.
Another question from the crowd.
I would say, what I would recommend is why don't we have they just ask the question, we'll repeat it.
Okay.
That way we're not sending the mic back and forth. And yeah.
Great.
So go ahead. So the question is about common security issues that you might end up dealing with from maybe a default Postgres configuration. I'd say, for my part at least, running the application as super user is like the #1 pitfall that people just automatically do all the time. You really want to lock down your users and what their permissions have, and what permissions they have right from the get-go as part of your development of your schema and the application and all of that. The other big one that used to be a gotcha that we've actually made progress on is create access on the public schema. Is something that we're actually changing, which I think is a big thing. So revoking the create right from the public schema from public is a common thing. Yeah, in 15 we changed that so that that won't be included going forward. I mean, there's probably other. Yeah, the HBA default. Well, on most of the distributions it's okay, but you definitely don't want to use the trust method for authentication. So that's a common gotcha if you're building from source. There's also a talk on this tomorrow, I'm told. So that's come to that talk and ask the same question. Yeah, great. Yeah.
One other quick thing, if you're into security, like really seriously, I'll pimp it. If you Google Postgres Stig, S-T-I-G, yeah, there is Stigs for it. I think primarily developed by Crunchy Data, and you can find that and kind of align that to your organizational needs.
Yeah, there's both a Stig and a CIS benchmark. So the Stig is DoD, DISA, and the CIS benchmark is more or less the same thing, but for commercial. Yeah, go ahead.
Get your security issues to Scram with better authentication and HBA jazz. Paraphrase.
But definitely use Scram for your.
And it has the word Scram in it. That's what I really remember.
So.
By the way, there is this opinion that passwords cannot be similar one to the other, and in Postgres, implementing that is actually insecure because you need to know what the text of the password is for doing that. And the way Postgres manages passwords, it doesn't know the real text of the string. So please don't try to implement that. You are not doing security.
I love certificate authentication, so I'm just saying. Yeah. If you're really smart, Kerberos. If you're not, certificate. Yeah. So there's the question is, there's a lot of talk about distributed databases, particularly Cockroach and Yugabyte too. What's the Postgres project's take on the implementation of distributed databases for the community?
I was just trying to remind you to repeat the question, but I got landed with it. Okay. I mean, I don't know that I necessarily would speak for the entire project. I'm sure each one of us has their own general opinions about that question. There's trade-offs with it, right? Just like there are with a lot of other things. When you start going into a distributed database environment, you're dealing with a lot of additional latency between the nodes, and if you end up having to do the kind of provide the kind of guarantees that you get with you know, SQL and RDBMS and ACID compliance and all of that, you end up having to do things like a lot of lock management that can be really painful between different nodes, things like that. So, you know, I think there's a lot of trade-offs there. I don't necessarily know that they're, you know, they're bad or good, but it's a different type of design of a system. You know, in terms of what Postgres is actively doing, certainly we're doing a lot of improvements with Postgres FTWs. We're doing a lot of improvements around things like partitioning, and so you can start building your own kind of federated environments using the various FTWs that are available, which are is a really very capable way of building out that kind of horizontal scalability that a lot of people are asking for when they look at a distributed database environment, right? That's really what they're going for, right? It's not that they want it to be distributed, it's that they're looking at that from a scalability thing. But of course, even with FTWs and things like that, you're going to have to deal with the complications that come with that. But I think you know, I would say the project continues to move in a direction that allows us to leverage multiple systems concurrently, as long as you're willing to accept the trade-offs that come along with that.
Yeah, I had a customer ask me this last week. They said, basically, where do you see Postgres can't go or has trouble going? And certainly embedded, I think the idea of us going to an embedded environment like SQLite would probably contort Postgres so much that it would not be a good move because we're more of a generic database. I think the distributed is kind of on the other direction. That to go in that direction with Postgres at this point would kind of contort Postgres in a way that would make it harder to use and more complicated to use maybe as a generic database. I think as we grow, again, as you were saying, as we go to foreign data wrappers, as we maybe have an ability to do distributed locks better, which would probably come with sharding, then I can start to see Postgres kind of moving organically in that direction as we have, you know, sort of sharding is going to be foreign data wrappers and parallelism and, you know, and partition push down, right? So would distributed eventually look like that with something like logic replication? EDB has a distributed Postgres, which is sort of taking Postgres and morphing it in that direction. I think it's really complicated when I see it now, and I'm not sure we would go that direction, but I don't know. The question, I look at Yugabyte or Cockroach and I say, okay, they took a dramatic step and went right to distributed and kind of left the non-distributed behind, right? I don't see us doing that. I think the real question is, would we be able to grow organically into that space? And I don't know the answer. It'd be interesting to find out. I didn't think we'd grow into sharding organically, and I think we will. So whether we're going to grow organically into distributed or not is a great question.
That actually brings me to a question that's been asked me. I think we've got questions from the internet, right? In this case, the internet is Mars. What do you feel the next big of the future that will further differentiate Postgres? It doesn't have to be in 15. What do you think the next big wall to climb?
Differentiate, yeah.
Differentiate. You can play Mark with it. Make him answer it. Pass the mic.
No, but that's not differentiate. That was my thought, but it wasn't.
It's not really differentiate.
It's not differentiate, no.
Actually, I think one of the things is,
So I do think one of the things that's interesting that's being worked on in that same space is client-side encryption that Peter Eisentraut's been spending a good bit of work on, and I think that, you know, that's a great direction, I think, for us to be going in as one option, right? I don't think it's the only option. I think TD is another way that we want to go, but I would say there are some other databases out there that provide those kind of primitives for doing client-side encryption, but it's not as, I wouldn't consider it as prevalent, right, as the more typical TDE that you see with, the other products that are out there. Yet, there's certainly advantages to doing the encryption on the client side if you're able to. There's disadvantages too, it's trade-offs. But I think that's an interesting feature that's currently being worked on. So so Bruce mentions table access methods. So I think it'll be very interesting once we get to the point of having an alternative table access method in core besides the traditional one that we have that's called heap. So this is, you're talking about things like zheap or Citus, columnar store. I think columnar in general will be interesting, but again, it's not really something that one would argue is differentiated, right? It's not, I think JSON-B would be a good example of something that, we really kind of took and ran with early on, that was something that wasn't as prevalent among the other systems. Some of the work that's been going into actually implementing some of the features from the SQL standard, I think period is one of them that has gotten some work that it turns out that there are like other database systems. Like it's funny because the standard will run off and write things sometimes and nobody implements it. So there are some things in that area that I think we may end up getting before other database systems, and that might be something that's differentiating us, even though the feature already exists in the standard. Right? Some of these features have been written in the standard, like match expressions and things like that maybe one other database did, but most of them did not. So those could be interesting things that I know that there's been interest in. I haven't seen a lot of patches for that though, so I don't know. It's all very, very early on in terms of the thought around those kind of things.
I actually feel like I don't keep up with some of the new development stuff as much, but how's that temporal data type looking?
I haven't paid a lot of attention to it over the last couple of months. I haven't seen one updated with this.
Jonathan, what do you think? Temporal. Now. In the future. Now, common now.
More questions from the audience before I have one? Yeah.
So you were saying about SCW? I used to, years back, we found the performance to be inadequate and it had to pull together the database so that it ended up with a different separation. Has any work been done on improving the performance on that since probably, I guess, 9 or 11? Wow.
Yeah.
So the question is, has FTW performance improved since 9?
Well, that's not really the question.
Oh.
Has FTW improved enough that it's worth looking into again?
Is FTW performing well enough today to look into?
Very large data sets and combination of queries between them.
So are you doing Postgres to Postgres? Yeah, so that's the big thing related to sharding actually. The Japanese and a bunch of people have all been pushing things like where clause pushdown, order by pushdown, join pushdown, parallelism of the shards, but parallelism along foreign data wrappers in a partition, pushdown of aggregates. So in 9, we just like threw the query down and like, oh, go do everything and then we'll filter it when you come back. And that was very naive, and because we've been pushing toward sharding, obviously that every year has gotten. My website has a presentation about sharding, and there's one slide that basically says, okay, 9.6 we did this, in 10 we did this, in 11 we did this, in 12 we did this, and in 13 we did that, in 14 we did that, and then, so there's been dramatic changes every year in that, yeah. I would say read-only sharding is certainly something that can be tested to see what you get numbers on. I haven't seen a lot of people excited about it, unfortunately. But I think it's ready. I think read-write sharding, we still need a better distributed lock manager and a distributed snapshot manager. Now, we have solutions for that, but we need to get to square one, and we haven't really seen enough people wanting to test it. Yeah. One of the things I think we may end up, the distinguishing question that we got, one of the things I think it has been distinguishing Postgres, for good or for bad, is the cloud deployments of Postgres. I mean, it's Google, it's Amazon, it's Alibaba, it's Microsoft, right? Everybody's got their own custom cloud deployment. And I think that the concept of some of the storage layer of Postgres moving into the literal cloud infrastructure customization is a distinguishing feature of Postgres because it's open source. Not necessarily done by the community, but it is a distinguishing feature of currently deployed cloud versions of Postgres. And I think that could have dramatically affected. In fact, Mahbub talked about using specialized hardware and stuff. So there's a lot of this lower level storage change that I think is going to be distinguishing in the coming years for Postgres. I think that's pretty clear because nobody else is doing it but us. And the numbers are crazy good. Right, so the point of the table access method might allow people to make a version of a cloud-specific or hardware-specific version of Postgres that doesn't have to fork the code and plugs into the table access method. That's absolutely correct, yeah. So I guess it's getting back to the question we had earlier, table access method and a cloud and a specialized hardware environment. Yeah, we're doing columnar and stuff like that, but I think this would be, in terms of performance, potentially orders of magnitude more important, I think.
I mean, so the question is about Postgres in containers. And I like to share a little anecdote of, I was doing Postgres in V servers back when V servers were a thing. I mean, I don't know how many people here remember that, but it was like a patch you had to patch the Linux kernel with, which was kind of the precursor to containers. So, you know, Postgres in containers is not actually something that's that new. And there are certainly trade-offs to doing it, right? Some people are not a big fan of it. I would argue that the issue with containers is less about the fact that it's a container and a lot more about the fact that a lot of systems have been designed around the idea that containers and often the storage underneath the containers are ephemeral, right? And it'll just go away. That's okay, right? Because we'll just re-download that or re-image it or whatever. And so you really have to be cognizant of the storage that you're using underneath the Postgres, which is true even in the non-container space, right? It's true anywhere. It's just that in the non-container space, it's a lot more typical to just have, you know, traditional storage that you know, where fsync works, right? Whereas in some container storage systems, fsync is quite intentionally not actually going to fsync things, right? So that's where you really have to make sure that you're using you know, the right storage modules underneath of Postgres and making sure that they actually do what Postgres needs them to do. So there's more to think about, I feel like, in you know, when you're deploying Postgres in a container environment. And so I think that's a place where you know, you just want to make sure that you've thought through those issues or work with somebody who does. There are other things around memory management that are also can be challenging in containers, which is arguably a Linux kernel issue. At least that's my consideration for it. And the Linux kernel people have been given patches to try to make it better, and unfortunately they have yet to agree that that makes sense. So that's an issue, but that's something that we're also working on the Postgres side to try to find a way to deal with that on the Postgres side to avoid runaway queries causing problems, basically. But in a reasonably managed environment where you don't have arbitrary queries coming in that end up sucking up tons of memory, it's not, that's not something that you have to stress about. You can work around it and address that risk that way. And of course, you have the same problem in a misconfigured Linux server. If you don't go set overcommit memory, right, you're going to have potentially the same problem of the killer running around killing things. Like it's not actually a new thing. It's just that in the container world, you don't have quite as many tools there easily available to prevent that kind of thing from happening, because overcommit memory in if we're talking about like Kubernetes or something, you can't set it, right? And you can't set it on a per container basis. So that's where it becomes a bit more of a pain if you don't have the ability to control what the queries are that you're sending to the database. But yeah.
So it's fine as long as you're not using Linux.
I'm not going to repeat that. Yeah, go ahead. Yeah, so in Leipzig there was a talk, or I'm not sure if it was a full talk, but someone was mentioning, there was a discussion about this kernel issue, and one of the approaches that somebody else had done was to essentially override malloc, right, and handle that inside of malloc by making sure that it had a cap, right, which is basically the same kind of thing as what I'm talking about, and I actually we're actually working on developing a patch for, which has been discussed on the hackers mailing list also, for tracking how much memory each backend is actually currently consumed, and then having that in shared memory where you can then say, okay, well, once we get to a certain point, we're going to be like, no, we're going to start failing, user-oriented or user-facing backend allocations, and that works just fine in Postgres, always has, right? In the event that we have a memory allocation that fails during like a hash join or something, we'll just happily, free up all the memory and fail the transaction, and off you go, and everything's fine, right? And so it's just a matter of getting something like that into core to address the issue that the kernel isn't doing that for us, unfortunately. And it's funny because the kernel patch is like only a few lines to make it work, which is, it's odd that the kernel is that much pushback. So if anybody happens to know any memory-oriented kernel developers who are around and want to talk about this, that would be really cool. But yeah, we're aware of that as a concern, so that's something. But there are lots and lots and lots and lots of people running Postgres in containers. So.
What are some of the biggest challenges for adoption of Postgres currently?
Anybody want to take it?
You wrote it. So you're right.
Mark keeps, sliding in questions. I mean, I guess, one of the challenges to Postgres adoption that I would see is exactly the kinds of issues I was just talking about around the server-side configuration pieces that you have to think about. Things like making sure that your server respects fsync, making sure that your server will fail a malloc allocation, or having control over the system enough to make sure that you avoid that risk of running out of memory on a system that doesn't have a way for the kernel to fail the allocation for you. It's, I feel like there's not a lot of people end up just deploying Postgres without thinking about these things, and then discovering that fsync doesn't actually work, so everything breaks, right? In the event of a crash, or they end up having the killer come along and kill the Postgres system, and they end up with a bad experience from that, right? So I think one of the challenges is working with the kernel folks and working with the storage folks to make sure that we have a way of telling them, like, here's what we need, right? So, in the Kubernetes world, things like the storage engines that exist there, we need to be able to tell it, like, we actually care about fsync here. Please make sure that this actually fsync works and that it fsyncs all the way down and is persistent storage. So there are some things like operators and whatnot that exist out there that try to help with this, but not all of those things exist today in the Kube APIs, and it would be nice if more of them did, and there's some progress being made there, but I do think just making sure that people have properly configured systems underneath of Postgres so that Postgres can provide the guarantees that we try to provide, but we need to have those OS level things set up in a way that that allows us to then make those guarantees, because otherwise people get a bad taste in their mouth. The question was about running Postgres on Windows. I will say that it's not something that I would typically recommend. However, there are folks that are doing it, and it's gotten better, right? We continue to make improvements to Postgres on Windows, just like we do to Postgres on other environments. I actually am. We're working on porting PG Backrest over to Windows finally. I know that that's something that a lot of people have been asking after, and we actually have someone actively working on that now. So that's something that will provide a solid backup tool for Windows. Another one. I mean, there's other ones out there, but I think that'll be helpful. One of the arguments I've always had about Windows when people ask me that question about Postgres on Windows is that it's not, Postgres could certainly be improved on Windows itself, but there's a lack of a lot of tooling that goes around Postgres that doesn't exist for Windows, and that ends up being a real problem when you're trying to deploy Postgres on a Windows environment. It's not the core server itself that's necessarily going to have issues or break, because we test it all the time, and obvious things are tested and checked and will work, but you don't have the same ecosystem of tooling around Postgres that you do on a Linux platform today. Anybody else want to comment on that? No? All right.
I just wanted to add that I think it's good to run Postgres on Windows. When we started doing that, we found a lot of bugs because Windows doesn't respect any standards. So we started to find that the code doesn't protect about this and about that. But unless Windows actually improves itself, which I don't think it will happen. I mean, the blue screen has been since what, 95, 98, and okay, it's now black, but it's there. And I remember reading a paper saying that SQL Server doesn't use the memory API of Windows. It uses the primitives. So I don't feel that Windows is something we can actually run smoothly. It's something it can be done, but I won't expect to be fantastic. It's a sad story. In Latin, people, I think it's everywhere. People think about money first, and while open source is actually less expensive, yeah. Well, its adoption is not zero cost. It will cost, and people doesn't want to invest on that because it's a 2 or 3 years investment until you actually see the money return. So, in LATAM, you can't think about 1 or 2 or 3 years investments because governments change rules too quickly. Yeah, so it's difficult. We need to learn to teach people, but with some companies, big companies, actually using Postgres now. Actually, tomorrow I'm going to talk about a Latin-based company, which is of the financial system, and it moves money for lots of companies in Latin, the West, and Europe. And with those cases of a study, people start using Postgres, start considering it. Sadly, those companies doesn't want their names to be mentioned. So I could be inventing things, you know. There is no way to confirm it.
Yeah, so the question is, are there enough Postgres professionals to really keep Postgres moving forward? And I guess so many people, compared to Oracle, yeah, we're a tiny group in terms of availability. And that gets to the larger adoption question. I mean, I understand, Stephen, to people who don't want to have a bad experience with Postgres, but there's a whole swath of people who are never going to experience Postgres for a variety of reasons, right? And they kind of fall into 2 camps, right? There's the one camp, which fortunately is getting smaller, which basically says that only relational databases from the big 3, you know, are enterprise ready, right? So it's IBM, Microsoft, and Oracle. Obviously, the ones like Sybase and Informix, they all gone away, and Ingress is on life support or whatever. But they still see those. For some reason, the other big ones who have left, they understand they've left, but the fact that these other 3 are still around, they still think they're really the place to go, and Postgres is just something you use if you're going to want to save money or whatever, right? The fact that IBM and Microsoft are supporting Postgres also doesn't register in their thinking. They're still thinking that those are still the better solutions. And it may be because they feel that they have better professional options. Right? They may think, all right, I'm not going to get involved with Postgres because that's going to be a step down in my career. I'm not going to command the same pay, or I'm going to, you know, I'm not going to be important in the organization anymore. It's a cost-cutting database, so therefore we don't put them. We're going to put it in low-level apps, and all the important apps are going to stay. So there's this psychological problem with adoption to get people there, and you know, when I talk to people, I basically say, listen, you know, Oracle's not going to be the gravy train forever. It isn't already. It's clear new people aren't really choosing Oracle. A startup would never choose Oracle, or almost never choose Oracle, you know, and it's almost a legacy database, all 3 of them. And obviously, anybody working in the legacy field, you know, then you end up like the COBOL programmer, right? They're not there yet, but it's the writing's on the wall, I think, in those cases. So when I talk to people, and you're absolutely right, we don't have enough people. So the only way we're going to get enough people is to get those people who understand these other databases to learn Postgres. And, you know, we've tried to basically, I've pushed training for these organizations to bring in people and do significant training, a week-long training that is targeted between their old database and Postgres, can use the terms that are the same, and the concepts are the same, so they can basically transition from one relational, because that's really the only way we're going to build that community quick enough. We can't build brand new people from scratch probably. We're going to probably have to pull from these other databases and get them kind of up to speed on Postgres. And I think it's been pretty successful if you see people coming from other relational systems. The other area where we've had a challenge in terms of adoption is people who think that relational is old, relational is not you know, where technology's going, and that somehow, you know, NoSQL is going to solve all the world's problems. That actually is in decline as well. You see less people thinking that NoSQL is, easier long term. It's probably easier short term. Sort of like, you know, putting together a go-kart is easier short term, but don't take it on the highway. So I think people are seeing the problems with the NoSQL, and I think Postgres is benefiting. So I think it's kind of over time we're kind of moving there, but it's always slower than I want it to be.
I just wanted to make a quick note about, I mean, if you look at DB engines, I mean, yeah, I think we are in a situation where we really need more people getting involved in Postgres and helping to move Postgres forward, but I don't think it's really holding us back that much in terms of actual adoption. When you look at things like DB engines and, you know, the huge markets that are out there for Postgres, I don't think it's really holding us back actually all that much. Sorry, somebody else wanted to add on something?
Yeah, I just wanted to know what the differentiator is. You said SQL or what else is MySQL? What's the differentiator between Postgres and MySQL and advantages?
That's great. We got 42 minutes into here before someone asks the MySQL question.
I started with MySQL years back, moved over to Postgres.
I feel like I should give the mic to Dave because he's literally doing a series. So for those who know, like, you've been posting, I guess it's on YouTube, right? Like, you're doing a series on like Postgres for MySQL DBAs. So there is a series of that for people that are trying to make that transition. Yeah, Dave Stokes, our esteemed, I guess, person in the audience.